We are live. I think so. We are live. Let me just confirm. I hope that we are live. Hi, Minal. Hi, Atharva.
Hello.
Welcome back.
Hello.
Welcome back. Let me see. Who all are there? Who all are there? Miss Nonchalant, Aditya is here. Stuti, Sony is here. All right. You know who is here. Sushant. My favorite topic ever, Mahmood. Excellent. Been too long. My last PFC workout. Excited for this. All right, chat. Welcome for today's stream. We are going to talk about astrophysics. Okay, Miss Nonchalant is telling us yes, you are live. Thank you, Miss Nonchalant.
Perfect.
Can you just confirm if I am audible? If my guests are audible? Hi guys, how are you?
Hello. We are
Hi,
good. How are
hello.
you?
I'm doing very well, thank you. There has been so much demand to get the second part of astrophysics going. And for the last 1 month, I've just been dodging questions. क्यों नहीं हो रहा? क्यों नहीं हो रहा? I think, guys, patience.
Yeah.
Time works differently in outer space.
Yeah, you can say that. That's one way to dodge the questions.
Yeah, that's what I told them. So there is definitely a lag between what we are talking about and the chat, but I think that's okay. So there's like a 10-second lag, guys. I'm sorry if I don't pick up on your comments immediately. It could be because of the lag. It could also be because of the conversation here is too interesting. But I hope that you'll forgive me for that. All right, guys. So what have you been up to in the last 1 month? Astrophysics related. क्या क्या पढ़ा?
बहुत कुछ पढ़ा है. There's been very new, interesting developments in the field.
Okay. Like what? Like give me a couple.
So there's this thing called time crystal, and
Okay.
it's
बहुत
a
mind
state
blowing
of
चीज है.
Yeah, that
हाँ.
sounds straight out of a
Li-
Marvel comic.
It
No,
does.
it's like literal mind blowing. Like actually
So
blow हो जाएगा.
it
What
is
what
like
is it? What is a time crystal?
state of matter that exists in 4 dimensions as well, like 4 dimensions. And so like our normal crystals that stay stable, like their structure is same throughout time, but in time crystal its structure changes from moment to moment, and it's like a jello, and it was just theorized ऐसे ही.
Like
Wow.
imagine that you are in a 3D space,
Okay.
and then
We are
also
just
imagine that you
45
have a
seconds into
time
the conversation
thing,
and my mind is spinning. Yeah, tell me, Atharva.
and then imagine that you are in a time thing,
Huh.
and then again imagine that time has internal dimensions.
So, okay. Is this like that string theory thing that instead of 3 dimensions, there are 9 dimensions?
Yeah.
So there are many theories,
Yeah.
like string theory is popularly known as string theory, but it is like M theory. So like there is M theory, then there are some theories with 41 dimensions. There are some theories. So like everybody has hypothesized something or the other.
Right.
But like, yeah, these are just new concepts coming up, and this is a very nice concept. Like it puts you to thought that what if time has internal dimensions? So like,
Wow.
And
what if?
Time has internal dimensions. So on the one side of physics, people are arguing that time doesn't exist. Like time is a construct, and time is like an emergent property of other things. Time itself doesn't exist. And on the other side, we are saying that time के अंदर dimensions है.
Yeah, and like there exists a matter, and you can use this matter, like people have been able to create some of it in a way, like lab में थोड़ा बहुत. I don't know how it works. Like I watched so many videos trying to understand it, and I still don't understand.
Yeah.
It's just too confusing.
समझने ही नहीं वाले, वो तो
समझने नहीं
दिमाग
वाले.
के ऊपर से ही जाने वाला है. That's
Yeah.
fixed. Going bouncer.
Which earlier, right, when I was reading stuff and I was just trying to understand, I used to get frustrated with. But now, when I come across something that I can't understand, I'm very glad.
Yeah.
Because then there is hope that okay, there is a lot that you still don't know, and if say I can't understand one thing, that means that before that thing there are 10 other things that I have to learn first before I can understand this thing.
Yeah.
Right? So one ununderstandable thing is actually the doorway to 10 understandable things, which is pretty cool.
That is such a good way to look at things.
Yeah, like, and so now I am in that state of mind. Okay, give me things I don't understand, and okay, I'll figure out the rest. I'll figure out how to get there.
It is fun. Like I think it was in your live stream you talked about how getting new information is kind of like a dopamine hit.
Yeah.
Yeah.
Isn't it? I mean, I feel like that for this stream, even for the coding streams.
Yeah.
I'm just here learning stuff, and every 5-10 minutes there is a boom in my mind.
It's fun to have
Absolutely,
that.
absolutely.
Okay. I don't
Okay.
know how many of chat. How many of you attended the last session? How many of you attended the first astrophysics session? Say yes. Say I was there. Yeah, just give me a shout out, just so that I know what all should I recap. I will recap, of course. Yeah, but I just want to know how many of you were there for the last one. And also, very, very important, as a couple of my mods have been saying, guys, like the stream. Okay, like, don't do that. Just like the stream, make it 150 or whatever. And quick, make it. All right, most of the people who are answering have attended it. I wasn't there. So whoever has not, don't worry. The link is there in the description. Go check it out. Guys, is today's discussion dependent on knowing stuff from that one?
Not entirely. Like
Not really.
No.
Yeah.
Right?
A bit.
Okay. So let me see if I remember. Okay. In the last discussion, we started off with the concept of time and astronomy, and how the primitive man needed to look towards the stars and the planets to have a concept of time.
Yeah.
Yeah. So the sun going around, climates, tidal waves, all of them related to gravity and seasons and the position of the North Star. So the idea of time was built on observing the sky.
Yeah.
Yes.
And we built on that, and then we talked about time. We talked about the different ways in which time was measured and how direction was measured. You talked a little bit about the seafarers, the sailors, and you talked about a particular
Yes.
machine that they had built to see the directions in which they were going.
Sextant.
Yes, sextant. I was trying to remember the name. And then we spoke about, we left Earth and we went to the solar system. We spoke
Yeah.
about the sun, we spoke about the planets. And I think we spoke about all the planets in the solar system,
Yes.
including
know.
Meenal's favorite, which was Uranus. And
Don't have to mention that.
and yeah, I think we were going to talk about galaxies, and then we decided that, okay, you know what, that deserves its own talk.
Yeah.
And that's where we are today.
Yeah.
1 month later.
Yup.
All right. So, okay, I'm not saying anything. That's fine. I was waiting for a long time. Chad was waiting for a long time, but okay, we forgive you. But
Thank
now
you.
that we are here, tell me how do we go about this? How do we understand the
Okay.
next step?
So we started with like considering ourselves and the planet
Yeah.
as a point object. That was our reference point, and we looked around the space, found various planets and our sun, the star.
Yeah.
Now what we are going to do today is we are going to consider our solar system as a point object, and we are going to look further into space and see what is there and how the sun that we have today, like how did it form, and like the entire process of star formation, the life and death of stars, and then galaxies.
Okay.
And then something which is everybody looking forward to, which is the goal of this talk.
Wow. Okay.
Some black
Lot
holes,
of suspense.
some mystery.
All right. Okay. All right. I can see that you are settling into this role of content creation.
Yeah, we're learning from you.
Okay.
Okay.
So on the first talk, the Earth was the point of reference, and we looked around us, and now our solar system is the point of reference. All right. So now, if we are standing on the solar system, what are we seeing around us? If you look around,
first, when you look back, or anywhere actually, you'll see like shiny objects that we have seen from Earth as well.
Yeah.
Like the stars, right? So we're going to talk about how stars came into existence. But before that, we are talking about very large distances. So we have to understand, like, put in perspective ki ye distance actually kitna bada hai.
Right.
So I might need to use my PPT for that.
Oh yeah, go ahead.
Yeah.
I want white holes with black holes. Utkarsh. Okay, that's a very specific request.
Yeah. Okay.
Please ask them if they've read the book The Fabric of Cosmos by Brian Greene. Oh, I've heard of this. I think Brian Greene has given a talk on this book.
Yes, he has. He had.
Yeah?
Yeah.
Oh, hang on, guys.
Brian Greene is a very famous fellow for publicizing astrophysics. Like, he has been on the Stephen Colbert show.
Right.
Everywhere, like. So, he and Neil deGrasse Tyson, obviously. These are the two people due to, like, they brought astrophysics to the normal
to the big stage.
Yeah.
All right. So Shant is loving that you have a PPT prepared, Meenal. All right.
Okay.
Okay.
So, okay, we'll just talk about starting with the first astronomical distance. And we'll like talk about why we use these distances and how they help us figure out things.
Yeah.
Okay.
BSNL OP. Nice one.
Okay, I think that it should be done now, but I'm just gonna wait for them to confirm. Wait, hang on.
Yes, I guess it's done now. No, but your screen is not full, I guess.
Yeah. I'm just doing that. I'm just setting it up again properly. So, 1 second. All right.
Yes, it's back.
Yeah.
It's very good.
Yeah.
Yes,
I think this is okay. All right. Okay, chat, can you hear me, see me, see everyone? Back to my live. All right. Okay, cool. You're back in our dimension. Share the experience. All right, we are back. All good. Tell me. Yeah, Meenu.
So, like, should I repeat what I said again?
Yes, please.
Yeah, okay. So, the first unit that we use is astronomical unit. And it is the distance between Earth and the Sun. That is 150 million kilometers.
Yeah.
Okay. And 1 AU is 150 million kilometers. And if someone says कि वो इन दोनों के बीच का distance 2 AU है, you just multiply that by 150 million kilometers.
Right.
So that is
like just instead of saying ki
1 kilometer,
instead of mentioning so much zeros and so much units, so much numbers, we just like physicists have that old habit, approximations. सब easy कैसे करना है देखने में, mathematicians and physicians, they don't want to extend everything.
Yeah. All right. Got it. Of course, it makes sense. You can't calculate those distances in kilometers, obviously.
Yes.
Yeah.
So like you need some realistic scales. So but now if we see ki AU hai, so like how do we say that this there is a thickness, right? There is, everything has a thickness, right? So like if you say ki I have a cube in front of me and I want to say that these are the dimensions of the cube. So in what variables do I say? I say ki x-axis, y-axis and z-axis. Basic.
Yeah. 3
but
dimensions.
if I take this cube far away, and then I want to mention its position of the cube, then what do I say? Ki it's as good as it is as good as a point. When we zoom into the picture, we see that the cube is actually 3D. But for us, when it is far away, it's just 1 point.
Right. Perspective
so like
matters.
Yeah, then the perspective changes. Then actually, from the perspective, the three dimensions boil down to one dimension.
Yeah.
So like you can directly give a point on the cube just by giving one. So
Yeah.
it's similar thing. So like that's why we say that we boil down something to dimensions, and that's why we like don't mention like the dimensions. Like the sun has some radius r, but then we don't mention it because due to the distance, like 150 million kilometers, and what
Yeah.
is the sun's radius in front of it? Nothing.
Hmm. Hmm.
So it
Yeah.
boils down to just one dimension, then as good as one dimension.
Even when we talk about the stars, we always just measure the distance.
Yeah.
The actual
Yes.
size of that star is of secondary importance because of the distance.
Yeah.
No, it is of importance, but yes, while observing secondary.
Okay, I think I understand what you mean. I think I get what you're trying to say. All right.
Yeah.
So,
So
AU, 150 million kilometers is 1 AU.
yeah.
Got it.
And what we said about dimensions, like when we think about dimensions, science fiction ने ऐसे कर दिया कि oh, there are different planes of existence and stuff, but it's not really that complex.
Okay.
It's as simple as a coordinate system to measure your position in the space that we live in.
Hmm.
So yeah, dimensions are just that. If a line, let's just consider हम लोग 3 dimension में नहीं है, because if we are in 3 dimensions, तो हमारे line को भी thickness होता है, right? But let's just say a line, it's in 1 dimension. Then if you add, so it has a length. Now we add a height to it.
Yeah.
That is 2 dimensions. And then we add a width to it.
Yeah. So
That is 3.
I always thought of how it's interesting that as your perspective changes, you have more and more dimensions.
Yeah.
So you might be looking at a dot, but if you change your perspective, it will suddenly become a line. Or if you're looking
Yes.
at a line and you change your perspective, it becomes a sheet.
Yeah.
So technically, dimensions are intricate.
Yeah. So I
So-
wonder if dimension is a property of the object or the observer.
Observer, obviously.
Interesting.
It is, yeah.
It's very interesting. Like that's an interesting concept because it what it literally means is expand your mind and you have more dimensions.
Now, like a similar analogy can be brought up in day-to-day life. So, how do we say that like our sugar is sweet and something is spicy? It isn't a property of that object; it's a property of the observer or the person who is tasting.
Yeah.
So, like it feels sweet to us. That's why we say that it's sweet.
Yeah.
So, like everything is from our perspective.
Yeah. Even when we see things, colors
Yeah.
is actually a property of our perception.
Yeah,
Yes.
we're gonna get to that again.
Oh, really? Okay.
Don't spoil it.
Okay. Oh, sorry. All right. Go on.
Okay. So the next unit of measurement is light years. People
Yes.
usually confuse it with time.
Yeah.
ये time का measurement है, but it's a measurement of distance.
Yeah.
So it is like एक साल में light कितना distance travel करता है? That is 1 light year.
Right.
And that is 5.8 trillion miles.
5.8 trillion miles. Okay, I'm not even going to try and imagine.
Yeah.
Yeah.
I
Okay.
So
don't
it's like
even know
हमारे
how
solar
much zeros
system
are
है
there
ना?
in a trillion.
I know you might as well have said billion, and I would have been okay.
Yeah, it's
But-
like 800 times the diameter of a solar system.
Mm-hmm.
So that is how much a light travels in 1 year.
Yeah. What is interesting is that our capacity for awe,
Yeah.
like all other physical objects, only works in a small range of spectrum.
Yeah.
If it's too little or if it's too big, we lose that capacity. Beyond that, if you would have said 1 billion or 1 trillion, I would feel the same amount of awe.
Yeah, it just generalizes out, like everything seems same.
Exactly. So just like the visual spectrum, beyond that
Yeah.
and below that, you can't see it, you can't perceive it. Similarly, you can only be surprised at things that you have the capacity to be surprised with. Beyond that, it's like, हाँ ठीक है.
So there is this saying na ki, our existence is like a universe's way of knowing itself. So
Yeah, that's very, very Very true.
You're so bound to your neuroscience thing that you say, like brain wala cheez hai, that we can't really tell what is real and what is not real. It's our personal truth at the end of the day.
Yeah. No, that's very true, because
True.
all of our consciousness, yours, mine, everybody in the chat, all of our consciousness is, we are all part of that universe. So
Yeah.
every bit of consciousness adds up. At least this is what I believe, that every bit of consciousness adds up to the universe being aware of itself.
Yeah.
Because the analogy to this is that every cell in your body is aware of itself, but in a much smaller way. Now, if I remove 10 cells in your body, you won't know. But if
Yeah.
I remove 1 million cells from your body, you might start feeling some effects.
Yeah.
Right? And the more cells leave your body or die, the lesser your consciousness becomes.
No, but the point, like, you won't know if we remove 10 cells, but when you see quantum world, so like very small world, or even normal, so like it is at such a balance that if you even remove some electrons from here there, then the balance would be broken. So like if you remove 1 mole of electrons from any random body, then they would experience such a great force that they will be thrown apart or attracted, so that they never get away.
Understood. The contradiction, or rather the counter argument to that is that the universe also comes with corrective mechanisms, just like the body.
Yeah.
So it's not, the imbalance is not absolute. So because the
Yes.
system has inherent corrections, if you remove 10 cells, the system corrects itself. So I don't know if that applies to that electron example you gave, but
It does.
yeah,
It does apply to fermions.
yes, that's
yes.
what I
Yeah.
like about it, that if you understand one subject very, very well, it's easier to understand everything else. You can extrapolate the core principles and the same things will apply.
Exactly.
Exactly.
All right, lovely. 1 second, people were saying change the OBS, correct the OBS. All right, cool. I did that. Meenal is love, yes. Bagul OP, okay, excellent. Try not to spam, fix OBS. Yeah, it's done. Can we all agree that OBS is fixed? It's looking great. And yeah, all right, we are going ahead. Astronomical distances, go on.
So it's just, how do I say, to put things in perspective.
Right.
So from Earth to Moon, it takes light 1.3 seconds. Like, and then from Earth to Sun to Earth, it takes light to reach Earth at like 8 minutes. Then from the nearest star that we know, it's 4.4 light years. So it takes the light 4.4 light years to reach Earth, and the speed of light is 3 into 10 raised to power 8 meters per second. So even at that speed, it takes years for the light to reach us. So it's
And Alpha
very
Centauri
fast.
is the closest
Yeah.
star cluster.
Yeah.
No,
It's
star. Alpha
Star.
Centauri is a star.
Yeah, Alpha
Yeah.
Centauri is a star, right?
So it's
And
from the Centaurus cluster. It's from the Centaurus constellation. Alpha Centauri means that the Alpha is like the brightest star in the Centaurus constellation.
Oh, that's what it means. Okay, so Centaur is the constellation.
Centaurus, yes.
Centaurus.
Centaurus.
Okay.
Yeah. And the
Alright.
maximum speed we have ever achieved as humans is 11,000 meters per second. So-
Maximum speed as in?
Like,
Anything technological
Oh,
speed
okay.
or anything, spacecraft or something.
Like that
Spacecraft, right.
Concorde? No. The
rockets.
No, Concorde was not even
yeah, I
close
mean
to
that just broke the sound barrier by some.
Yeah.
yes.
Yeah.
We have our rockets that go at 11 kilometers per second. Alaji.
Wow.
Yes, because they have to exit the
escape.
Earth's
Right.
gravitational pull.
Right. And
But
of
that-
course, once they leave the Earth's gravitational pull, they'll be going much faster.
No, they go at the same velocity they leave. So there is no acceleration because there is no medium. Like there is medium, but like you understand that there is no need for acceleration.
You're just floating. पानी
It's just
में,
floating. It's just
Random
going.
thought.
Yeah.
You're saying you can't accelerate in space?
You
can.
can. You can.
You can.
Huh.
You don't need to.
You don't need
That's
to. Yeah, got it.
But yeah, you don't need to.
Because nothing is stopping you.
Yeah, there's no friction.
Yeah.
हम लोग मस्त उड़ रहे हैं.
Uh, make it sound very like a vacation. Okay. Go on.
So anyway, these, just to put it in perspective, ये हम लोग basic use करते हैं.
We are
units.
really
There is-
far away from everyone.
यार, too far away.
Yeah,
I don't
mean,
want to think
to
about
the
it.
moon is 1.3 seconds. Like
Yeah.
Light
suppose we're
seconds.
traveling by light speed and 8 minutes तक sun. Just think about that. So 8 minutes अगर हम चल के जाएंगे, so that's like the shop near our house, and 4 years चल के जाएंगे.
That is,
Yeah, like another city somewhere far away. That is how far the nearest star is.
yeah.
Yes, but then if you travel at light, then there is this mass change and everything starts happening at relativistic effects.
Right.
Because like we, for our normal calculations, for our normal velocity acceleration problems, we take our velocity of light to be infinite because like it doesn't matter. So if we start talking about velocities comparable to the speed of light, so like then relativistic effects come into action. There
It's
is
a
some
whole
distortion in mass and everything
Right.
like that.
So yeah, so that's where things get weird because when we say light year, year is a unit of time, and if you are talking of speed at that level, time changes.
Yes.
So then
Yeah.
how can you say light year?
No, but it's
It's
just
for like-
nomenclature. It's just
हमारे
speed
लिए-
into time is distant.
Oh my god, my mind is going. Oh, okay, got it.
Yeah.
Nothing is real, guys. Nothing is real.
I'm gonna start crying at this moment.
So I just realized that if we are not careful, this
Yeah.
is the kind of trip that leads to ends up with you sitting in a room throwing bananas at the wall, muttering nothing is real. You have to be very careful.
Yeah.
Guys, go meet your family, okay? Tell them you love them. Just be around friends and family, okay?
After this conversation, I
After
used
this conversation. Oh my god.
till then
And
we'll
in
just
this, like, just a warning, in this talk, we are going to jump from large astronomical scales
Yeah.
to
very
atomic
small.
scales.
Yeah.
Yeah.
Jump, like literally jump.
How?
Okay,
Abhi
we'll
slide
start.
dekho.
We'll get to that. All right. Go on.
So, before we understand our macroscopic world,
Mm-hmm.
we should understand microscopic world because that is what governs our macroscopic world.
Okay.
Yeah. So, what we know is this is an atom,
Yeah.
and it's not what we see 11th 12th के books में वो ऐसा shells वगैरह नहीं दिखता है.
Yeah.
Right. And so it was considered for a very long time to be the smallest, atom means indivisible.
Yeah.
People were like, this is the smallest thing that
You
has
can't
ever.
break it up.
Yeah.
Hmm.
Later on, we found out that you can break it up.
Yeah.
And once you see that it is made up of electrons and protons and neutrons.
Right.
And this is a whole different field of physics itself. But I'll just touch upon the basics, and we'll just look at apna 11th 12th ka trauma. That is
Oh yeah,
this-
that's familiar.
Yeah.
Finally, something that looks familiar.
This is a very, like, they should be sued for this theory, this picture. People should be sued.
Bhai, itna
This is a crime, actual crime.
Well, it's more so from what I understand, there are no circles. It's just like these random spheres of electric.
Not even spheres. There are dumbbell shaped anything. So like there are clouds, electron clouds. So like you can't certainly say that I will find the electron at this given point as given in this picture. You can't find these two electrons sitting over here opposite to each other.
Right. So
You have an electron cloud and there is probability of finding electrons somewhere.
In that point.
Yeah. But
And
tell
we'll
me this,
talk about.
if you
yeah.
didn't know this
Hmm.
diagram, could you have learnt enough to know that this diagram is false?
No.
I mean, this is the problem with all the things that I said are scams. Right? I mean, we know that they are scams, but we can only say that they are scams after learning about them. If somebody tells you that the atomic structure cannot be described because there is a probabilistic equation that can define a structure, what will a student in 9th standard say to that?
They'll go crazy.
Yeah, I was in 8th standard. I knew this was fake.
Oh, you know it was fake.
Yes.
Like, you
What
took one look
smart
at this
is
and
that?
said fake news.
No. So like, we were taught कि ये fake है.
Right.
Oh, okay. I used to believe this is the thing till 12, Baba.
Yeah, even I believed it. I was very trusting. I thought
Yeah.
everything they told me was real, and then it was much later. Aditi Patil, thank you so much. Thanks for discussing science and physics. Love these streams. Panel OP. Do discuss about multiple dimensions and string theory if possible. Panel, is that coming?
Yeah, that might come.
Yeah,
in,
that
not
might
But
today.
that will come on a different, yes.
Yeah.
Now that somebody has said it, now that it's there in the
You got
universe,
it,
it'll
do
happen. Alright, continue.
Okay, so let's just see कि बीच में जो है, that is the nucleus, and it has neutrons and protons, and ये छोटे छोटे जो है, that are electrons.
Yes.
Now they say, oh, electrons का negative charge है, protons का positive charge है. These charges, you can't really see them on the electrons. They're just, we have put labels to their properties.
Right.
That's it. Now, this atom is something that we are all made up of. And the arrangement of electrons defines what element is there,
Right.
right? So, but at the end, हम सब atom है. And these are considered to be 99% empty spaces.
Right.
At their scale, they are empty spaces. And there was this guy who, I don't remember his name, but the person who learned about them being 99% space, he was scared to stand up on the floor because कि उसे लग रहा था वो नीचे चला जाएगा जमीन में. So yeah. Just
Yeah,
fun
because
fact.
it means that we are basically all standing on empty space.
Yeah. And
Actually, but like that 1% is there, and we have so many of them that 1% like boon se sagar bana actually.
yeah.
Right. And the good news is that, guys, don't worry, you are also mostly empty space. So if that's any comfort to you, empty space can't harm you. You are also empty space. So guys, that's the take-home message. The next time you feel that the world doesn't make sense, you don't make sense either. So
Oh my God.
it's fine.
Okay. That took some other turn.
Yeah, if the world is empty.
Each milestone in physics makes you realize that sab moh maya hai.
I swear, man. I swear. Okay. All right.
Okay.
We are at the
So-
elementary table.
We have seen this, and what we saw, this atom that we saw पहले, उसके electrons के हिसाब से we get these
Right.
elements.
Right.
Now today we're going to learn कि ये elements actually किधर से आते हैं. ये हम लोग Earth पे पैदा नहीं कर सकते आधे से ज़्यादा. And they are forged into various big.
Wait.
explosions.
What did you just say? That you
These
can't make
elements.
these elements on Earth.
Not all of them.
Okay. So
Some-
you're saying that all the elements that are there on the periodic table, all of them don't exist on Earth.
No.
They
Iron says,
exist. They exist.
but you can't create them from scratch. That's what I'm saying.
Okay.
You need something or the other. So like looking at this periodic table, people have said that okay, these are inorganic elements, these are metals, these are lanthanides, these are actinides,
Right.
these are something, these are highly electropositive.
Yeah.
From an astrophysical point of view, there are only 3 elements: helium, hydrogen, helium, and metals. So like after helium, from 3 to 103, everything 118, everything is metal, termed as metal.
Yeah.
Because helium and hydrogen are the only one which are like 99% of the star content.
Okay.
So like everything other gets synthesized, we call it metals.
That's interesting, because it's like what you're saying is all you need is one and two, and you can make the rest of the numbers
around
from that.
Yeah.
You just need hydrogen, not even helium.
Yeah, correct.
Hydrogen and a lot of gravity and other things.
Obviously,
Hydrogen and a lot of energy.
Yeah.
Gravity, yeah.
Gravity.
Everything, gravity also.
Okay, got it.
So, to put in perspective how small an atom is, एक orange लिया, उसमें जितने atoms है, so number of atoms in an orange is equivalent to if you fill Earth size का एक बड़ा सा glass है, ठीक है, उसमें जितने blueberries भरोगे ना, that is the same amount of atoms that are there in an orange. ये छोटू सा चीज.
Okay.
They're that tiny, so they fit in.
Like blueberry to Earth is atom to orange.
Yeah.
Okay. Excellent.
ये भी ठीक है.
अभी बोल ही दिया तो ये भी ठीक है. Alisa Khan, it gets more confusing as it goes on. अरे अभी तो शुरुआत है.
Atoms again. They are
but
divisible.
this is not confusing.
This
is
I
not.
mean,
Yeah, I mean this is
Mesmerizing.
elementary, my
It's
dear Watson.
mesmerizing.
Yeah, this is just interesting. Absolutely. Okay. Now what is this? This is going to be confusing because I don't know what this is. Yeah.
we won't talk about these, Isna, because this is like particle physics.
Yeah, but we'll just touch upon it. Like I'm curious to know what this is.
So
Well,
basically, our particles, which we say like electron, photon, and neutron, even they are divisible. Like not electron, but like even they are divisible. So like proton bhi hai. Like there is something less than proton. There is something less than neutron, from which these are formed.
Okay.
So these are these subatomic particles we say.
Okay. So
So
can you just
Higgs-
tell me which are the colors? What colors represent what?
So these are the quarks: up, charm, top, down, strange, and bottom. These are the 4 quarks. So like there is this ground mass given in terms of so these are very small. So masses are given in terms of light, like speed of light and energy, obviously. So like giga electron volt by the speed of light square. So these are the masses, and there is charge and spin given over here.
Where?
Yeah, यहाँ पे ये देखो.
Oh,
Over
yeah,
here.
yeah. Okay.
So like
Chat, I don't know if you
minus
can
1
see
is the
that.
charge of electron,
Right.
and accordingly there are these charges.
One
And
second. I
spin
think I
is-
should. I think I should just make it a little bigger. Hold on. Just one sec, chat. One sec. I'll just make sure that you can see the thing properly. Hold on. All right. Is that
Somebody
better?
just posted confusing is the new interesting.
Yeah. What?
Confusing is
bouncer
the
gya.
new interesting.
No, guys, okay, 1 second. It's not bouncer. Just wait. Atom है, ठीक है? Atom के अंदर protons है, atom के अंदर एक nucleus है, और nucleus के round electrons घूम रहा है, और nucleus के अंदर protons है और neutrons है. इतना 12th में पढ़ा था, ठीक है? अभी वहां तक पढ़े थे और उसके बाद हम लोग सब लोग आर्किटेक्चर और आर्ट्स और कॉमर्स में चले गए और nobody picked up this thing because obviously but Atharva said screw that, मुझे और पढ़ना है. And so if you break down an electron,
not electron but sub atom. So if you break down an atom,
Okay.
there are not only electron, proton or neutron, there are something much more.
Okay,
And basically
so-
neutron and proton are made out of these.
okay, so you can't break an electron.
No, electron is a fermion. It's like it stays there.
Oh,
Lepton,
perfect.
fermion.
Okay. So you can't break an electron. So यहाँ पे electron is shown as a part of leptons.
Yes. So it's a fermion basically.
Okay.
Screw that leptons, quarks, scalar bosons and Gauss bosons. These are some much more advanced topic जो
Yeah.
मुझे भी definitions इतना पता नहीं है, like
Yeah.
like I
just
know, but
to-
not to the amount that I can explain it to
Right.
general public. So like these are the two main categories, fermions and bosons.
Huh. Okay, so
these are
bosons
mainly
on the
classified.
right. So the red and the
Yes.
yellow ones are bosons,
Yes,
and the left ones are all fermions.
fermions.
Yeah.
So
And the
like
bosons
these
are
are
what gives you
segregated.
mass.
No, these are segregated on like एक energy का ये रहता है. Suppose मैं एक energy पे हूँ,
हाँ
तो मेरे साथ और कितने particles हैं
हाँ
उसी energy पे,
हाँ
उसके हिसाब से fermions और bosons का segregation
किया
है.
है.
If
Yes,
there
sir.
are only one or two particles if on the energy,
हाँ
then it is a fermion.
Huh.
If there are n number of particles on your same energy with you, then it is a boson.
Okay, so bosons like to hang
Basic.
out with more bosons.
Yes.
Okay.
Yeah.
Okay.
So it was not to confuse anyone, बस दिखाना था कि और बहुत सारी चीजें हैं जो हमें नहीं समझती है.
Right. I remember this joke on bosons. Like Higgs boson went to church
Okay.
and they said that subatomic particles are not allowed. And Higgs boson said, but without me you can't have mass. So I remember that joke, and that's just one thing that helped me remember that, okay, boson particles give mass somehow. I don't know
Yeah,
anything आगे पीछे.
it is a field जिसके through particles जाते हैं.
Right.
And since it is a field, it stops a particle from escaping at the speed of light. And वो अटक के आगे बढ़ रहा होता है in the space and somehow gives it a mass.
So basically, these leptons, now to like a bit mention, there is a difference between quarks and leptons. Leptons are basically discrete particles.
Huh.
And using quarks, you can form particles, but leptons are discrete particles.
Okay. So all these particles, okay, let's just step back a little.
Yeah.
All these elementary particles or subatomic particles, they all have charge, right? Some charge.
Yeah, like we have, you can say that, yeah.
I mean, it's given, okay, some of them have zero charge. Okay.
Zero, yeah.
Got it. So at least, okay, let's say this. They're all defined by the charge, their spin, and their mass.
Yeah, and spin is not गोल घूमता है.
Okay.
It's just we have decided कि oh, this is a reference 90 degrees, okay, in space. Now वो कितना bend हुआ है, like at what angle it is.
Right.
Tilted. That is the basic.
That is spin.
Yeah, that's it.
Okay. So I've heard of quantum spin, and I've heard of two particles having opposite quantum spin, and you change one and the other changes, and
quantum entanglement
and all of that. And I love that we are talking about all this in astrophysics. Like, how did we get to here? Yeah, tell
it's
me.
The universe.
Tell me, how did it get? Tell me, why are we talking about this?
Because it's very important to study particles before studying what is in our galaxy or what is in a star.
Yeah.
Because basically this is what makes all that possible.
Right.
Yeah. So whatever we see here is there in the universe. We see it directly with the eyes or not, that's a different thing. Now we'll talk about light.
All right.
So with light, we have to know that whatever we see call, and it is this. ये जो color से
yeah.
Okay. So this is what we fall into the visible light, and it is a huge spectrum of electromagnetic radiation.
Yeah.
I really don't want to get into what electromagnetic radiation is because it's बहुत ज़्यादा लंबा चीज़ है.
Yeah.
But let's just say कि there is a radiation and it has a wavelength. Okay. And we can see things only in these wavelengths.
Right.
बाकी का wavelength is dark to us. That's why we see dark वाला चीज़.
Yeah.
Now, on this side of the wavelength is radio. It has like सबसे बड़ा distance उसके wave में.
Yeah.
And at the right side you have gamma rays, right? So gamma rays are so small that, let's say, with respect to an hydrogen atom that we talked about abhi,
Yeah.
atom kitna chota hota hai? It is 10 picometer or something. That is how small it is. And to put it in perspective, let's just say कि if the gamma ray का जो wavelength है is the size of a coin, एक रुपए का, then the hydrogen atom would be the moon.
Wow. Okay.
It's that small.
Blown.
All right. Yeah. Okay. That blew my mind.
Yeah.
I just have one question.
Yeah.
So all these things, right from radio waves all the way to gamma rays, are all part of the electromagnetic waves. They're all
Electromagnetic spectrum. Yes.
Spectrum. Yeah.
All right.
And
Cool.
how do we get these waves? Like, we'll go to that थोड़े time में. So let's just say radio waves कितना बड़ा है? It is bigger than the diameter of Earth. So
Wait,
it's,
what?
Yeah.
ये देखो ना, मतलब 10⁻³ meters, and the radius of Earth is 6,700 kilometers, ना? Meters.
1,400. Yeah.
हाँ.
Wow. So there are
So, like,
radio
comparable.
waves that can cover the entire Earth and go.
Yeah. वो इतने बड़े रहते हैं ऐसा roller coaster.
Oh my god. Okay.
And these are all around us. We just can't see it.
Right. And in a way, I mean, it sounds weird to say, but in a way, they also have their own color. If we had receptors that can get stimulated by that frequency of energy,
Yeah.
we'll be able to see it. Right? Because everything that we see is receptor dependent. So there are people born without the receptor for the red cone, for example. So they can't see red. It's color blindness.
Yeah.
So they can't see red. So then everything they see is in shades of green and blue. And that just means that in the Vibgyor spectrum, a red is the least wavelength, like the lowest wavelength, highest frequency.
Yeah.
So you can't see color in that part of the spectrum. So your visual spectrum actually becomes less. So if it can become less, theoretically, it's possible that it can become more.
Yeah. I mean, I read as
Now
to
that
why.
depends on the genes, right? So like if there is irregular expression somewhere and something happens.
Yeah.
I was reading about
Or
why
technology.
we see, like in
Or technology. No, technology has been advanced, so we can we can convert, we can map those like multi-wavelength data
to our
into
visibility.
something like false colors.
Right.
But anyway, wait, I was saying that I read somewhere that why we see visible light okay, so this wavelength is something that is known to pass through water without any destruction. Okay, like it perfectly goes through it, and the first life form that formed is said to be in water. So it's kind of like an evolution wala cheez. So water mein you can see these things very clearly.
Damn.
Yeah. So now, are you okay?
Oh damn. Yeah, okay. I have to go and read about this. Yeah, I mean, I just got a random thought, but yeah, I have to go read about this. Cool.
Okay. So these question आता है कि light, right? Like how is it formed? To put एकदम simple ways में there's like बहुत complex चीजें हैं. But let's just say अब ये अपना atom है. ठीक है? ये electron है. He's very excited. He's like, oh yeah. And then उसका energy drop हो जाता है. And it just goes to a shell below it.
Right.
Now उसका energy drop हुआ. We have a law of conservation of energy. So it's not destroyed. That energy just goes into something. And that energy is released from this electron that we call the photons. Light is made up of photons that we say.
So it depends. Like actually, no,
Yeah.
it just like it gets ejected as a
Ah.
from in the form of an electromagnetic wave. Now,
Yeah.
what form is it depends on from which energy state it is coming to the lower energy state. So like the energy difference. So it can be X-ray emission. It can be infrared emission.
Yeah.
It can
Yeah.
be photon like gamma ray emission.
Yeah.
Anything.
Yeah.
Or
So
even not even in the electromagnetic spectrum. Does it have to be in the electromagnetic spectrum? Can it be other forms of energy like heat and sound?
Heat is an electron. So
Electromagnetic.
basically, you associate energy with temperature.
see.
Okay.
So in many fields of physics, you can write temperature as energy and energy as temperature because they are directly proportional. Average energy for some systems is said to be 3/2 kT, like you might have studied in the 11th, 12th, or 10th.
Right.
So like we can actually
I'm sure I
convert
did.
these to using just a constant. So like they use it synonymously.
And okay. And what about sound? That is different.
So yeah, so this is a different kind of wave. Sound is a different kind of wave. So like this is what we
Yeah.
call the transverse, and that is a longitudinal wave.
Longitude.
Yeah.
Yeah.
And sound needs a medium. I think that's the main, like probably one of the main differences.
Yeah.
Because sound cannot travel without a medium. So if there's a firecracker bursting in space, no one can hear it.
Yeah. You can't.
You can't.
Yeah. But you can feel the temperature. Like you can feel the heat.
Yeah.
And you can
Yes.
see it.
Yes.
All right. Of course. I like how I like how I brought all of you down to like ekdam basic level. Okay.
So that was the plan. So
Alright, continue.
doing the okay. So light, we talked about light because that is how we see things and it connects us with the universe.
Yeah.
So I just wanted to mention कि इसके basic properties क्या है. And yeah, now we'll go to the next part. So light has some properties.
Yeah.
There's like polarization. I just thought कि I'll put it in if
Yeah.
अगर explain करने का मन किया तो let's see. So light ऐसा travel करता है. Okay, this is an unpolarized light, and when you put a filter, it just seems like ये जो है, it just goes up and it's like a singular wave now. So
Plain
to see,
polarized light.
yeah. So now, if you see, when we wear those polarized glasses, right, it actually uses that phenomena. And यहाँ पे this is unpolarized. You can see a lot of glare over here, ये पानी पे, and यहाँ पे the glare is reduced.
Right.
So just a little demonstration of what it would look like to have a polarized light, because we might use that futurist
Yeah.
man. Now the colors that we see that have different wavelengths
Yeah.
themselves, and yeah, so you just a visual representation.
Vibgyor. Yeah. This we know.
Yeah.
This is the rainbow.
Yeah.
Hmm.
And now, so we take
And just like that,
pictures.
we are in outer space.
Yeah. Straight up.
Right off the bat, suddenly, we were just thinking of neutrons and yeah, amazing. All right.
So, so this is, let's say, a Crab nebula. This is what it would look like to our normal eyes.
continue.
But let's say infrared, अगर इसमें देखना है, on the infrared spectrum, then it would look like this. Or radio wave में ऐसा. Or there are variations to how you see it, depending on what instrument you use.
Right.
Okay. Now, there is a very complex thing going on over here itself. कि ये colors कैसे आए infrared में,
Yeah.
या फिर
Like it's like I always wondered this from the start, like from the beginning, from like school before like 8th, 7th grade, like okay, अलग radiation में दिख रहा है, but मुझे तो blue, red यही दिख रहा है वापस.
Yeah.
So why? So like this is through like there's a mainstream data processing pipeline they use. So like so what happens is when you take the observations, as I guess mentioned in the last stream or on your Discord channel, I guess, just go back there, like see if you want. So basically, there is this plate, suppose, and you are sprinkling some sugar on it.
Okay.
So one particle of sugar may hit one part of the plate and it will stay over there. So like that, there is a plate in the camera. The photon will hit over there and that pixel will get illuminated.
Okay.
In some kind of way, like the
Right.
intensity of the photon hitting is the illumination, be it anything. So basically what do they do? They take this matrix basically, including the intensities of the photons hitting, then they convert that into a data map, then they convert that into a color map by normalizing it accordingly.
Right.
So like RGB में होता है ना, like we have 0 to 255.
Yeah.
So like that, they convert that and then they basically get these false colors.
Got it.
Because these are like creating representations of the sky view for our eyes.
Yeah, because we need to it's like language, like you have to translate it to something you can understand.
Yes.
Yeah.
Otherwise it's unintelligible. It doesn't make any sense.
So in a particular given language, you take the semantics, you take the
Right.
words, and you then convert those into the other semantic language, and then you convert that language.
And
so that's the same thing.
Obviously some things will be lost in translation, but it's better than nothing.
Yeah.
Right.
Yes. Or those some things are technologically balanced by like reducing the noise, taking dark images. So like first I will keep the shutter open, take this image, I will close the shutter, I will take again image. So that would be a black image. And what would it cancel out? It would cancel out the thermal noise.
Okay.
On the plate.
Right.
So this is like standard mainstream photography, which is scaled up to
that
this level.
astro level. Okay.
Astro
Yeah.
level.
Beautiful. Okay.
Okay.
Got it.
So now we have various astronomical objects in space.
Mm-hmm.
Right? This is not an object, just ignore that. So we have planets, stars, again, then there's nebulae, galaxies, black holes, and then voids.
Okay.
And much more, but
I didn't know voids was a thing.
Yes,
Void?
void is a thing.
Yeah.
I
Void is
thought
basically
void is the
nothing.
lack of a thing.
Yes, void is basically nothing. So it's an object, nothing.
It's a
Amazing.
paradox in itself, but
So
yeah.
you see, this is another milestone. It's nothing.
Yeah.
We have defined nothing as something.
Yeah, मतलब void को भी नहीं छोड़ा. Amazing.
Okay.
All right. Okay, 1 second. Just go back. There were a couple of somebody had mentioned in the chat that talk about brown dwarfs and also just I'm just curious about brown dwarfs. What are they?
So they are something like intermediate things who are not even stars, not even planets.
Okay. Okay.
It's
Because of
abandoned
their
object.
size, because of their contents, and that is the most pondered upon object in astronomy, like one of the most. Like, how did these origin?
Yeah. Like why are they
Like,
there?
what's the origin? How do these evolve? So, and some some people say that these have ages beyond the age of the universe, because
How can
these
that
are
be?
not even unstable, or like, people give any theories, but then they provide some explanation with it. Then that makes us think that, oh, if this person is right, then what?
Yeah.
Okay, so when you say they are not unstable, that means what?
So basically, what happens in a star is there are some reactions.
Yeah, they'll eventually become a white dwarf. Or
They have some fate, right? They have some fate.
yeah.
But these are objects. These are objects in which that fusion or reaction doesn't take place.
Okay.
And
So
they are
like
so dark.
there is one picture, I guess, which says that
No, so
the
1 second.
balance-
If there is no nuclear fission happening, wouldn't that make it a planet?
no, that's the point. So it shows many characteristics of a planet, a high like gas giant, and many characteristics of a star. So like it's on the intersection. So there has to be some intersection, right? So like
Right.
there has to be some point where things start transforming into the other object.
Got it.
Couldn't they just be like thrown out of the solar system because of some force and then वो अकेले लटक रहे हैं उधर?
I don't know like how,
Amazing.
why.
I didn't.
No
I've
idea
heard of
why.
brown dwarfs, but I had no idea they were this interesting. All right. Very
Yeah.
cool.
Oh, they are much interesting. So like there is a picture where we say that a nuclear fusion is balanced by gravitational pull
ये तो spoil
in
मत
a
करना
star.
और
Okay.
In over here there is no nuclear fusion, so we have to balance the gravity by something.
something that is inside.
So that is interesting. That's
Okay.
where your
This
particle
is
physics comes in play, which we
right.
explained in the previous
You
slide.
know what?
What?
I feel like gravity deserves its own discussion.
Oh yeah, it
Just
does.
the idea of gravity and the idea of okay, something that I find very interesting.
Mm-hmm.
The idea of how gravity interacts with other forms of energy.
Mm-hmm.
Like gravity with electromagnetic, gravity with light, gravity with sound, all of that. Just I find that very fascinating. Maybe we can talk about that sometime.
Yeah, and we'll touch upon that in the
Yeah,
talk a little bit.
done. All right, go on.
Oh, now we have a star.
Oh wow, finally we have given birth to a star. All right.
Yay. Okay, so what are stars exactly, and then why do they shine? Their structure and their life cycle. That is what we're going to talk about.
All right.
This is our sun, and it
Someone
is very.
familiar.
You see this thing every day. And let's just say sun का mass कितना है? So sun का mass है 1.9 into 10 raised to power 30 kgs. Okay. And there are ways you like I don't know how क्या बताऊँ मैं, like how did we calculate all of that, you know.
Yeah, it's okay.
Yeah.
I'm going to
Yeah.
believe you.
Just believe me. Yeah. So
It's
now
pretty straightforward, but okay.
yeah, it's like gravity के
Yeah.
you can do it.
Like how much weight should it have to exert the kind of gravity it does
Yes,
to
basically
keep us
that
all in circling? Yeah.
simple mathematical calculation.
Got it.
Yeah.
Got it.
So now this mass is considered as one solar mass, just like how we consider one
Yeah.
AU.
One AU.
Yeah, it is similar. Now we have the process of formation of a star.
Okay.
There is a dark cloud. Where it comes from, we're gonna like touch upon it बहुत last में.
Right.
But let's just see कि अभी एक cloud है, gas है. It has clumps of matter इधर उधर ऐसा,
Right.
dust, gas, and everything. And things start like coming together, and then gravity pushes things together साथ में, and then you form a छोटू सा ball, and then it just keeps on attracting more matter, and it keeps on expanding.
Yeah.
Now, as it keeps on expanding, there is a point where what happens is hydrogen molecules, they are separate. ठीक है? Now you're forcing them together.
Right.
Now they will interact and then they'll form helium. Now, it is like it takes a lot of years to have that.
Right.
But let's just say that is the process. So hydrogen, helium, ये बन रहा है, and that is what is happening in our star. So what happens? अब ये सब एक साथ आ रहा है, hydrogen, and since you're forcing so many small particles in a small space, they're trying to burst out as well, but then
Right.
कुछ हो नहीं रहा है. So energy बाहर निकल रहा है. It's fusion, right?
Yeah.
And बाहर से gravity धक्का दे रहा है कि
Right.
तुम लोग अंदर जाओ, and they're like नहीं जाना है. So somewhere at some point, according to how much matter is collected, they find an equilibrium, and the star then keeps on burning, and it burns till its death.
Right. So it's like you are constantly striking a match, and at some point there is enough friction, and then it just kickstarts
Yeah.
that chain reaction. And once that chain reaction starts, it will use up all the hydrogen there is,
Yeah,
right? And it will just keep on going.
it will. And like not forever.
Yeah.
But in this process, then बहुत सारा dust एक साथ आ रहा है, बहुत सारा dust बाहर जा रहा है since it's trying to throw it out. इस process में planets भी बन जाता है. So that
Got
is
it.
how a solar system forms.
So the planets I can totally understand because the star is already there, and the
Yeah.
star has the gravitational pull around it to create the planets. What I was really interested in is the A and the B and the C part. So
Yeah.
we are talking of, okay, basic question. Are stars still being formed?
Yeah.
Yes, obviously.
Yeah.
Yeah.
So it's not that all the stars are formed at the start of the universe.
No,
No.
it's a
It's
process.
a continuous process.
Reproductive system जैसा.
Yeah. They die, they form, they die, they form, they die, they form.
We'll see that entire process. आगे
Alright.
आगे.
Cool. I'll keep that question for later then. Alright.
Okay. So this is like a very basic understanding of how it forms. It's a very bada sa explosion and shit going on over there.
Yeah.
This is
All this
large melangenic cloud.
Okay.
It is near our galaxy.
Yes.
And ये सारे stars newborn stars है almost. एक star forming region है यहाँ पे सब
And
बच्चे.
then you can see some star forming regions with pinkish shades of color.
Right. This is
These
like
are the star forming regions.
star kindergarten. This is where all the
Yeah.
Bachu stars are getting formed.
Yeah.
Alright.
So
And then you can see these red shiny objects. Oh, go back, go
Yeah,
back, go
yeah.
back, go back.
Huh.
Yeah, then these you can see these red shiny. These are some older stars, so like red giants or like
Oh.
so the blue ones are older stars. The red ones are new stars. My bad.
The red ones are new stars.
Yes, the new one, the red ones are
Yeah.
new stars.
Okay. And those brown structures are nebulae.
Not nebulae. Just
that's gas.
magnetic dust.
Okay.
Magnetic dust.
yeah.
Okay. And just in a line, what are nebulae?
So we'll get
आएंगे
to
उस
that.
पे भी आएंगे.
We'll get to that.
We can't like go linearly on this topic, so yeah,
Yeah.
it's gonna be a bit confusing in the
Alright.
start.
Cool. Go on.
Okay, so this is the star ka process. Okay, stars be come in various shapes and sizes, and not shapes but sizes. This is a nebula, and then there's the gas starts, collapsing. There's a protostar.
Right.
Now, protostar के आगे क्या होगा? अगर वो massive star बन रहा है, after some point in its life, it will become a red supergiant. How does that happen? It's a process of chemicals being, क्या बोलता है? Hydrogen, helium हुआ.
Right.
Now, then after a while, helium के ऊपर भी gravity force करेगा, right? खुद को.
Yeah.
And then helium will form more elements, and
Right.
it just keeps on happening.
Yeah.
It will form metals.
Yeah. And at
Oh,
some
that's why
point,
it's easier. You don't have to
Yeah.
remember
Yes.
kya. It's just it forms metals.
metals.
I get it. Yeah.
So after that, like this entire process happens, and it goes into a blast. It's a big ass blast, and then it either turns into a neutron star, or if it is big enough and it can't really be crushed into one small ball of gas or something, then it turns into a black hole. Now let's just take a chotu sa star.
So 1 second. Star forming nebula is where all this is happening.
Yeah.
Protostar.
Yeah, planetary nebula. No, star forming nebula. Yes.
Yeah.
Yeah.
Then protostar, massive star, supergiant, supernova, and that can become either a neutron star or a black hole,
Yes.
or it can go back to becoming a nebula.
Yeah. Not with if it's like, I don't know, chota hona chahiye star.
Okay. All right.
It-
Cool.
Big giants
And
ka mostly
this was one pathway it could follow.
Yeah.
Like it forms a star of the size of the sun, so like mid-sized stars, and then it goes to the red giant. So after that, it forms a planetary nebula, then a white dwarf,
Lovely.
or
Yeah.
it can again go in a then that nebula can form either a red dwarf and then a blue dwarf, or a
Violet.
white dwarf then a black dwarf. Aisa.
Damn. It's
It
like a
looks
roller
like
coaster. It can just go anywhere. It's also
yeah.
like the infinity
No,
symbol.
it just cannot go anywhere. It depends upon the star, the mass, the composition,
Yeah.
the age. So yeah, this picture would be better shown. It is better shown by the HR diagram. So
Huh.
like this is a very qualitative picture of what possible pathways it can follow. But if we see the, I don't know the pronunciation,
Hair.
Hertz is something.
Mm-hmm.
So like if we see that HR diagram, then we actually get the mathematical thing like luminosity versus the temperature, what's happening.
So you can predict
Hmm.
what is going to be the outcome of a particular star.
Yeah.
Yes,
Wow.
So
you can actually predict what is the outcome of our sun using that.
that's a supernova.
So supernova is a star bursting.
Yeah. We'll talk about like how it collapses. It is just to like basics सा देता है कि ऐसा structure है.
Right.
They will explain bits and pieces of that.
Wow,
So
this is
supernova से एक है कि there is this Orion constellation. We had mentioned it in the
crazy.
last
Yeah,
talk.
yeah.
So in that there is a star called Betelgeuse,
Huh.
or people call it as Betelgeuse or something like that. Pronunciation doesn't matter, but still. So that star is a red supergiant, and it is on the verge of collapse and forming a supernova.
And
We
that
don't know when,
supernova-
but we know it is soon.
yeah.
Yeah.
And it is such a strong force that it could cause
It could
extinction.
light up the 1/4 of the sky.
And
for
appease-
like
And
a
it
month
can
or
affect
year.
us also.
Yeah.
Yes,
Oh,
very large.
excellent. Excellent. All right.
So,
Random thought. Shout out to Hitchhiker's Guide to the Galaxy. I mean, when you said Beetlejuice, yeah, whatever.
Yeah.
Yeah, one of the main characters of that book came from that solar system.
Yeah.
From
Yes.
that system, and Ford.
Yes.
Yeah, I just remembered it. And also, he talked of how Earth is situated in the unfashionable end of the western arm of the galaxy. Like,
Yeah.
so the rest of the universe
Yes.
thinks that यार तो अर्थ में क्यों जा रहा है और कोई जगह नहीं मिला क्या? Earth is the least fashionable of all the places in the galaxy. I just
maybe that's why we haven't seen any aliens yet.
yeah, it's not cool. It's not cool to come here.
Yeah, I mean climate change. So anyway,
I like that reaction when you said that. So you asked like, well, can it affect us?
Yeah.
And then we said yes, and then you were like, excellent.
so there is a possibility that it can cause extinction हमारे planet पे भी, because those rays.
But it's after a much greater
yeah,
point. So-
Yeah,
a
I mean-
very long time.
Yeah, we're not talking like before the pandemic is over or anything. No? Bas, that's all. ठीक है.
Betelgeuse.
If
So
we have
this
time to
Betelgeuse,
like,
which is
get out, meet a few people, I think we are sorted.
So this Betelgeuse, a red supergiant, this actually started dimming since 2019.
Oh, that's recent. Wait, what?
Yeah.
Yes, so it started dimming since 2019. Dimming is like it is almost reaching that phase. Like ऐसे brim saturation भाई बहुत हो गया मैं फटने वाला हूँ.
ए भाई तो स्ट्रेस मत दे यार हम लोग सिर्फ सीखने आए लाइक टेंशन दे रहे हैं
Tension, it is going to be a very
What?
Interesting.
beautiful scene.
Yeah.
yeah going out with a bang all right
So.
wait, what is
let's-
this what is the last one that you showed me yeah this one
This one, it is like an artistic impression of
Beautiful.
what star formation can look like.
beautiful
So,
I'm going to make my next OBS overlay as this picture
please
Oh.
do.
I love
So
it
pretty.
I love it this is made to be an OBS overlay
Okay.
This is such an artistic impression. Marvel का लगता है इतना artistic है.
yeah amazing I love it okay
Okay.
go on
So, wait, before this, we'll go to spectral classes.
mm-hmm.
Now, the color that we see of a star. He said the blue जो थे stars, they were like, you know, नए, या फिर
Yeah.
the red ones were पुराने वाले shit.
No, ulta.
No, sorry,
Red
blue
ones are
were,
pura naye.
हाँ,
Blue are very hot
The
stars.
blue are
Yeah.
the
Very
old
hot.
ones, the red are the new.
yeah,
Yeah.
Not exactly.
No.
Red are cooler and blue
Cooler.
are very hot.
But isn't that intuitively wrong?
yeah,
I mean,
it feels
hasn't
like,
that bothered anyone?
So that's the point. Everything depends upon what an object absorbs and emits.
Right.
So this is ulta. See the point. So it's like absorbing red, and therefore we are getting to see it as blue.
Yeah.
Because emission ही blue हो
it's
रहा है.
hot. So
Yeah.
Hot.
I don't know.
मतलब
It's just,
temperature.
it's just intuitively wrong.
it feels very wrong
It
to even
feels very
say
It feels
that.
very wrong.
Yeah.
So
But-
somebody's asked that is it possible that the supernova has already happened and it's not
Obviously,
reached us
yes.
yet?
Yes,
Yeah,
yes.
yeah.
It's very,
Very
too
possible.
many light years away. So like, yes.
How many light years away?
It is possibly. It is
Uh,
possible.
It's millions of light years away.
Oh,
I don't
millions
know.
of light
No,
years
no,
away.
no, not better though. No, not
कितना?
that much.
Just
I like how you
Let
said
me-
beta. नहीं बेटा उतना दूर नहीं है. बेटा उतना दूर
ना
नहीं जा
नहीं
सकता
है.
हमसे.
It is
Or
only
is it gonna explode
650
in
light
millions?
years away. Roughly 650 light years away.
650
So-
light years away.
yeah,
Yes.
it's gonna explode.
It's very close.
Yeah.
Okay, so 650 light years away. Okay, so in the last 650 years, it could have become a supernova at any time. 649 years.
Yeah.
Amazing.
Next year मजा आएगा. Okay.
Yeah, we think 2020 is bad. This is just the trailer. All right, go on.
God. Oh yeah, from what you said, I just wanted to put this out as well. कि the stars that we see are not like हम उनका present time में नहीं देख रहे हैं. Like उनका light आने में अगर 4.4 years लग रहा है, so we are seeing the star that is 4.4 years old. So just to
Yeah.
clear it out for those who don't know.
Correct.
Yeah. So yeah. Anyway, so the temperature and color ka correlation is this.
Right.
And then there is this diagram that Bagul Bhai was talking about.
Mm-hmm.
The HR diagram. It's based upon luminosity and the surface temperature.
Okay.
Okay. So, do you want to explain it, Athar?
So less temperature, less luminosity will make it a white dwarf.
Mm-hmm.
More
Yes.
temperature, more luminosity will be a supergiant. So this is the
Yes.
extreme.
So basically, this is a main sequence, the
Right.
band that you see in
ये
between.
जो है ना, ये.
Right.
So basically, many stars, what happens is they enter the main sequence and then they keep oscillating in itself, going up, ऊपर नीचे, ऊपर, उधर ही main sequence में. So maximum lifetime of the star, it spends in the main sequence.
In the main sequence. Okay.
Yes, and then after that, temperature and size के हिसाब से it goes into red giants, blue
All white.
giants at the top, or red supergiants, and these are white dwarfs. So like they are completely different.
Beautiful.
Luminosity or बहुत hot and very less luminosity.
Beautiful.
So-
Beautiful. Okay. Got it.
This is like the most important thing
Hmm.
in astronomy. Like, it's not even an exaggeration at this point.
Right. So this
So
this
basically,
diagram.
Sun is a young star,
Haha.
Yeah.
fairly young star. It has to go much.
No, how did you deduce that it was a young star from this diagram?
It has to go above. It has to take some path, either or udhar. So now it will keep on oscillating in this itself. People have taken observation over the years, and theory says that it's a young star, and therefore it is most probably going to end up as a giant and then a white dwarf.
So the age can also be like told with कैसा अंदर fusion हो रहा है, right?
हाँ.
Like
Spectrum से.
hydrogen, yeah,
Right.
spectrum से पता चल जाता है.
Right. So all the stars in the main sequence are young stars. You can sort of... No, it's not like that. Okay.
That's the main sequence of how a star, like उसके life में ये आधे से ज़्यादा time ऐसे ही रहता है.
Okay.
So like it's like डॉक्टर बनने को कितना सीखना पड़ता है, मैक्सिमम लाइफ सीखते ही बैठते हो ना तुम लोग. So basically ये है वो.
Wow, we just compared so many different things. All right, okay. That's fair. So yeah, most of our life we spend in main sequence until we eventually become a dwarf and die. All right.
Or super.
How weird. What a weird medical story. All right, continue.
Okay, so stars का luminosity है ना, like how much energy they are radiating. That can also be used to tell कि उसके सामने planets है या नहीं. Let's say ये star है.
Exoplanet discovery.
And उसके जब सामने से star रहता है, you can see that there is a dip in its what do you call it, luminosity.
Yeah. So I have done this in Python actually, taking data and then like classifying it into either confirmed exoplanets or candidates or false exoplanets or something.
Amazing.
So,
okay, so depending on the planet going in front of the star.
Yeah.
So basically it can be a planet, it can be its binary partner. Like if it's a binary star system, it can be a second partner. So Sirius star was thought to be as a single star, but then we saw a bit wobble in the star's like movement. We saw a wobble.
Okay.
Then we said that there is something causing that wobble. So there has to be someone, either it's giant planet or either someone. So, but that wobble was too much. So like the center of mass was a bit much away from the star.
Right.
That's why we said that there has to be something. And then further things led to saying that this is a binary star system where Sirius B is our white dwarf.
Oh, so until then we didn't know about Sirius B.
No.
Because a white dwarf can't be seen.
It's very low luminosity.
Right.
So luminosity helps.
So like तब तक technology नहीं थी इतनी observation की white dwarf दिख जाए.
So you have to logically figure it out कि इसके because there's a wobble there has to be another star next to it and so on.
Other thing next to it.
We don't know what.
So like Jupiter और Sun में भी थोड़ा सा wobble रहता है because of the two masses, the center of mass is on the radial part of the sun, near the radial part of the sun, like away from the center towards the radius, radial surface. So like there is a wobble in sun's orbit also, if we see that from a third person's perspective.
Understood. I mean, I think I understand. I'm sure there is a lot that I don't, but yeah, the initial bit I think I understand. All right.
Yeah. So, well, just astronomy is filled with beautiful pictures, I thought.
Oh, yeah, that I agree. I think you can pick any astronomy picture and use it as a wallpaper.
Yeah.
All right, 1 second. I'm just going to see if chat is with us or not.
Okay.
Right? Okay. So, I think on the whole, chat, you tell me now. Have you been with us so far? How is the discussion going? Is it going too fast? Is there anything specific that you want us to talk about? And yeah, wait. Okay, there's a lag. I think I put the I think I put the normal latency one. Please talk about Tabby star. I don't know what is Tabby star.
Neither do I.
Yeah.
Neither do I. What?
Okay.
Can you repeat that?
Super chat.
I didn't see that.
Why can't we measure speed of light, especially in one direction? What if dark matter accelerates speed of light in space?
See, dark matter is not yet observed. It's just a simulation.
Right.
It's just a thing that can make us understand why we are missing so many things.
Yeah. So it's like a basket. It's like a basket where you can put in all your unsolved equations and say that dark matter must be doing this.
Yeah, maybe इसने किया होगा सब.
Brilliant.
Yeah.
It's like we have circled back to religion.
Oh my god. Okay.
What? No.
But okay then.
I did not see that coming.
I mean, I'm just saying.
I will question my degree entirely then. No, nothing.
He's taking an offense.
No, no. So I'm just setting the stage where I'm sure you will explain to me how that is absolutely not the case. Astrophysics is a humbling experience, Mahmood. I agree. You can't read about this for a long time without thinking of our own relative importance to the scheme of things.
Yeah.
Yeah, I agree. Okay, people are saying that it's amazing. They've been there with us. Superb discussion. Thank you, Vishwas. Thank you so much. Dark matter is the imposter among us. Interesting.
We don't know even if it's there.
Yeah, we don't know.
Yeah.
We don't even know if it's logged into the game or not. Please talk about God particle. I think God particle was the
Higgs
boson.
boson.
Bose-Einstein condensate.
Yeah. Talk about singularity.
Yeah, we're gonna
talk
read
about
there.
Star Shot. What? Star Shot project. I don't know what that is.
What? Star Shot project.
Yeah. Please talk about Methuselah star. That's
Yeah.
People are
Why do I
requesting
feel
like their
that the
favorite
crowd
hits.
is too much knowledgeable in this?
Methuselah is like the oldest star in the universe.
Really? What?
Yeah,
Really?
it is. Yeah, they say that like they have named it that way.
Damn.
And for a very long time, people thought कि universe से पहले हुआ था, and I was like, how does that make sense?
Wow.
Yeah, there was a lot of
That is
confusion over
such a
there.
cool description to a star. That's the oldest star in the universe. Amazing. Okay.
Yeah.
Please talk about.
Yeah.
Okay, now people are just showing off. Are they googling it on the side?
It's
I'm
just
pretty sure
pop
people
science.
know a lot.
Sure.
Everything is pop science.
Schwarzschild radius.
Yeah. We're gonna talk
Schwarzschild
about
radius.
that.
Yeah, we are going to come to that.
Pluto left the chat. Okay. Talk about time dilation.
Yeah, we're gonna talk
Amazing.
about that too.
All right. Talk about Indian astrophysics scene.
Oh my
Okay.
God, yeah.
That's very
What?
interesting.
Athar, Indian astrophysics scene.
Scene matlab, what do you want?
अरे हम लोग उस दिन बात कर रहे थे ना साइंटिस्ट अपने इधर
Acha, हाँ, yes. I am going to bring up on my Insta account.
Yeah.
Keep a look.
Like, what are you going to do there?
So basically, many people don't know the Indian scientists
Yeah.
we have who have worked, who have contributed a great in physics
Yeah.
itself.
Yeah.
So like we if we just tell names of Bollywood stars, they know. But it's sad that people in science don't know who have contributed in science.
Yeah.
I said salt.
So like shout out to those people. That's why we have to give that.
Yeah, that's amazing.
Yeah.
So if you are going to be talking about that on your Instagram feed, that'll be very cool. Guys, do follow Atharva and Meenal. I've tagged both of them in the description, and yeah, Wasim has just put up their Insta handle. So yeah,
Thank
do
you.
follow them both. Okay.
Yeah. Now we're just gonna look at pretty pictures for a while because what heavy conversation हो गया है.
Done. I think this is going to be the most popular part of the stream.
So this is Crab Nebula,
Yeah.
and it is a remnant of a supernova explosion. And it was that they say कि इसका जो supernova हुआ है, people on Earth have observed it in 150 AD. 150 or 1050 AD. Yeah. And like when you talk about supernova, that it is so bright it will outshine a galaxy.
Okay.
And like it will feel like एक और star है हमारे बड़ा सा sun के जितना.
And if it is in our own galaxy, it will just travel like thousands of light years. The remains, the dust, the gas, the particles.
Yeah.
They will travel just thousands of light years, and then like obviously so much width in one single sky, and thousands of lakhs, much greater than
A
that.
supernova would obviously be constantly expanding, right?
Yeah, it's spreading.
Yes.
Yeah,
But
so
that
can we
is
watch it
so
in
slow
real
that we
time?
cannot see.
What?
Once the star has exploded, once the supernova is in being, the later on process is so slow that we cannot actually like see the changes to our naked eye. Obviously, if we take observations, regular observations, we can see minute changes, and then we can say what's the evolution of this getting up and then how can we expect it to behave,
Right.
etc.
Interesting. All right. Aditi Sharma just sent a super chat. Is wormhole just a pop science concept?
As of now, yeah.
Yeah, right?
It's
Yeah,
a
like
theoretical,
theory
it's
hai.
hypothesis
Like,
basically.
I like that description where you fold a piece of paper and you put a pencil through it and you
Pencil.
say that you can travel from one point in time to another.
Yeah.
But
Then I hope we get to do that. I hope
sure.
it's real.
Why
You
not?
are getting popularity on your piano, Meenal.
Oh my
Yeah,
god.
somebody said Meenal piano OP.
Meenal piano OP, Ritvik Mohan.
Do you know how to play?
Yeah, a
Okay.
little bit.
All right. So maybe we can end the stream with that. All right. Moving on.
Okay. So this is Pillars of Creation.
Oh, I've
It
heard
is
of this.
found
Oh,
in
wow.
Eagle Nebula, and it is so pretty. And Atharv, you were saying something about the pink stars.
Yeah.
मुझे कल बता रहा
Yes.
था something.
What? No, I forget.
What?
They just knew like
Something
said
about
about
the
it.
pillars.
Yeah. Like, these are pink regions, so like much younger star forming regions, we regard them as a pink, like regions in the cloud or dust or gas nebula or anything.
So this whole thing is gas, right?
Oh
I
yeah,
mean, cloud dust. Whatever.
dust.
Yeah.
Yeah.
Yes.
It
dust.
has छोटे matter, like clumps, but yeah, that's it. Then
It's
this-
basically a fluid. We can regard it as a fluid.
Is this
The
called a rose?
action of
no, this is
no.
I
This
can
is
see a
called
rose in
something.
the middle.
it's not.
All right.
See, I don't believe the people who just gave names on how it used to see, because there is a Canis Minor constellation, which I hate that person because he just saw two stars and named it as a dog. He saw a dog in it with just two major stars.
Yeah.
Atharv has very strong feelings about things.
Yeah. Also,
Okay.
I realized that when you name things based on how they look, how they look will keep changing, especially if it's a gas cloud.
Yeah.
So there's
Yes.
no point in naming them what they look like now.
But these were named back in 1000 ADs or something, right? Like by those people, ancient names. So like उनमें इतना होता तो मतलब
वो
अभी तक
constellation.
डार्क मैटर खोज लेते अपन.
भाई,
It's a
okay.
walnut, okay? People are seeing random things.
Oh my god, yeah. So हमारे astrophysics के class में university में we'll just put up pictures and guess कि ये किसकी तरह दिखता है and what is the name.
Like a Rorschach test.
Yeah.
So different people will see things according to their own personality.
Yeah, it is a fun process.
I see a
But-
face. Shri R said Amal Kumar Rai Chaudhary, who developed the mathematical formulas which helped Sir
Roger Penrose, yes.
prove that black
Yeah.
holes can really form. That is so cool.
We
The
have
current Nobel Prize, this year's Nobel Prize, Roger Penrose.
Amazing. Amazing. All right.
we have so many unsung heroes in science that even I
No,
am
but
not aware.
Penrose family has given a lot to physics.
Yeah.
His dad also.
Yeah.
Mhm.
Meenal, are you okay?
Yeah, I'm just
I'm
getting
getting
caught.
worried now.
No, it's okay. Is it disrupting the stream or something?
No, it's fine. You can, if you feel like coughing, you can mute it, or you want to take a break or something like that. Or
Oh,
vice-
no, it's good. It's
Cool,
good.
huh? Okay.
Yeah.
Cool.
Okay. So
Continue.
this is Carina Nebula. I hope I'm getting the name right, but it is spelled as
What's it spelled like?
Carina.
Okay, I'm just gonna type it. Cari.
Carina.
Carina.
I don't know.
All right. Guys, can you just check it if that's... It's not Corona, Anurag. I know we have Corona on our minds, right? It's not Corona Nebula. Please talk about multiverse. Okay.
Okay.
No, what?
Yeah, we're not talking about multiverse.
Yeah, not now.
We can't. We just... we don't have the time for it. If we did have a multiverse, we would have time for it. But we don't.
Parallel universe.
Yeah.
We would be sitting in a room taking this interview.
Correct. Yeah, maybe in another parallel universe we are talking about the multiverse. Fun. See how deep that is? Okay, continue.
Yeah. So this is NGC 604 Nebula.
Mm-hmm.
And this is what it looks
Is that
like.
the kind of name Atharva approves?
Yes.
Not
Give
Canis
it
Minor.
code names. Code names.
Like it is based. There is a nomenclature for naming these things.
Right.
So
Yeah. Right.
So
uh,
basically, this is a globular cluster, right? If I
um
am not wrong. NGC, hai na?
NGC
So
604.
it's a globular cluster in the between. You can see those pink star forming areas.
Right. So all the stars are formed in such nebula.
Yeah.
Yeah,
Yep.
including ours, our
Yeah.
sun,
It was, yes.
and it was formed there, and then it came here.
No, it didn't came here. It just the everything got
Settle
settled
down.
and नेबुला के हर चीज में से कुछ ना कुछ हुआ.
Right.
So we just stay there. So now this thing, it is 1,500 light years across. इतना
Right.
बड़ा distance है इसमें.
Right.
So yeah, these things are massive.
Okay, and then everything stars form, and the rest of the dust just disappears, settles, goes away, and only the stars remain. Something like that.
No, that is then formed into a protoplanetary disks or something like that. That goes into planet formation. That goes into something others,
No, what I'm saying is,
asteroids and all.
if we were to look at our solar system from a very, very far away distance, would we also see a similar picture like this? Like, are we
If
also
we
in a
were
nebula?
seeing, if we were seeing the birth of our solar system, then yes.
Yeah.
So
Oh.
basically, a star forms, and then the remaining thing across it just acts as a fluid. Then it evolves, and
Fuels
then
जैसा.
there are other objects that form. Those are planets, asteroids, dwarfs, and dwarf planets. I mean, so like these things out of the remains that form
So they all
that are
they
there
all
after the
come
star
and
forms.
envelop and just get everything ready, and then they just disappear.
Yes, so everything has an evolution process.
Yeah, this sort of sounds like embryology.
Oh.
Yes, exactly embryology.
This is so cool. Oh my god. This is so cool that this is
We are just miniature versions of what
The
actually
universe
is
is.
there.
the universe is.
Yes.
Because for a star, like a star cannot form in isolation. Like a star needs that whole system, like a setup,
Mm-hmm.
right?
Yeah.
Mm-hmm. Yes.
Okay. Cool. So it's gonna transform himself into Rick. What? Oh, Rick
What?
and Morty.
Oh, Rick and Morty.
Yeah. I don't mind. I mean, I find him pretty interesting. Okay, now what are we looking at?
This is HH object HS161
Mm-hmm.
and HH164.
Mm-hmm.
Okay, and ये उनके आसपास का dust है. Now इनका जो energy है, that is pushing away this gas, and that is why we have this thing.
So the interaction between these is pushing away these things.
Yeah.
Right.
So you can see like it actually मतलब magnetic repulsion जैसे होता है ना, मतलब एक forces act and therefore we get certain orientation of the dust, iron dust.
Yeah.
वैसे ही है basically. The forces are acting and then we are getting some patterns.
Amazing. Okay.
And this
Oh,
is
come on.
cat.
This is just pure embryology now.
Really? Oh,
This
oh
is-
my god, yeah.
It just looks like a
Yeah.
baby getting formed inside a placenta and like oh, come on, yeah.
We are all bound by the same laws of the universe, so you
Yeah,
know.
what are we looking at? What are we looking at here?
So this is Cat's Eye Nebula,
Uh-huh.
and this is the X-ray version of it.
Huh.
Like X-ray इसमें है. But yeah, it's pretty, so I put it there.
It's beautiful. It's so beautiful. Wow.
And then this is okay. I am gonna SNR BO 509 67.5.
Nobody is going to care.
Wow.
अच्छा दिख रहा है, मस्त है.
Ha, actually.
अभी.
Looks like a bubble.
So
Like a
these
red bubble.
patterns also form due to astrophysical shocks. So there are shock waves generated in each process.
Oh, did you do a name drop right now?
Yeah, he
Yes,
did.
that's actually the reason I took my Insta handle like that.
Okay, so what are astrophysical shocks?
So basically shock waves.
Okay.
So you know shock waves, right? So like if you if you take a fabric and if you like
Yeah.
extend it and then you tap in between, there are waves or ripples. So these are shock waves,
Yeah.
type of shock waves. So there are astrophysical shock waves of fluid dynamics.
Mm-hmm.
Like taking fluid dynamics to
To the
astrophysics,
astro level.
the
Yeah.
plasmas and everything form astrophysical shocks.
Okay.
So these shock waves and such like those dynamics of the waves give result in these particular shapes as we can see. So like if we boil this down, then we can actually see circles or concentric circles.
Yeah.
If you can.
Somebody said that I can still see a face.
Yeah, I mean, yeah.
Yeah, I'm sure if you look hard enough. So one of the characteristics of human behavior is that if you look at it anything long enough, you can see a face.
Isn't it like apophenia or something?
Something like that. I don't know
One
the
guy is asking, is math related to science?
Oh my God.
Yes.
Bro, maths is the thing which we count upon for each and every movement in science.
Okay, what are we looking at here?
This is Tycho.
I think,
And-
did you just Google awesome pics in astrophysics?
No. These are like my favorite ones out there, so I have always had them saved. And they
Wow.
have been my wallpapers.
Of
So,
course.
Hey, you had to put that one. It's not actually a phenomenon. I guess I had just taken some cosmological simulations off the net and I was practicing it on Python. And I had simulated one with a gas density. I'll put it on the Discord server, like keep up.
Yeah.
Like that's
Tell
a
him.
really
Oh yeah.
beautiful.
So Meenal, can you share all these pictures on that server?
yeah, Discord. Yeah, I will.
Yeah?
For sure.
On
Yeah.
that Learning Astrophysics channel. Alright. Move on.
Okay. So, yeah, this is Tycho. Then again, this is a supernova
Yeah.
explosion thing happening, and this is an X-ray again.
Mhm.
And then this
Yeah,
is
here I have to agree that look like Corona a little bit. Alright. Fair enough.
oh,
What?
yeah, it,
No.
yeah, it does. I
little
can
bit.
agree.
Yeah.
Yeah.
Okay.
So this is called the Oyster Nebula, and it is a planetary nebula.
Planetary nebula with a
So a planetary nebula is one that creates planets. No.
no, not actually.
Okay.
It's
that
just
that
very
doesn't make
small.
sense. A
Yeah.
star will have to form before planets have to form.
Mhm.
Yeah, got it.
So now absorb. So whatever colors that you see, right,
Mm-hmm.
in here.
So basically, planetary nebula is just something that forms around a aging star.
Hmm.
So like basically a ring-shaped nebula or something like that forms. It's basically expanding gas that forms around a aging star.
Okay.
So like if you can go back to that picture, so you can see the star in between,
Yeah.
in the middle.
And
So
few
the
stars.
nebula is forming around that star.
Oh.
That's a planetary nebula.
Right. So every planetary nebula will have one aging star inside it.
In the middle,
Middle.
in the center of it.
Ooh. Damn. Okay. Love it. All right. Someone working on classification machine learning models work with us. So says Discord. All right.
Yes.
Cool. People
Okay.
are with us. All right.
Okay. So this is like absorption spectrum.
Mm-hmm.
So the colors that you see, so you can tell कि उसमें कौन से elements है
Right.
just on by looking at कौन से colors absorb हो रहे. Like if you take this spectrum उस image का,
Mm-hmm.
you can see कि oh इधर black है, इधर black है, इधर black है. And these patterns can be found in sodium जब sodium रहता है किसी इसमें. So you can tell by the spectrum of that thing कि इसमें कौन से elements है.
Hmm.
So that is how people can tell कि oh ये इसका बना है, इधर sodium इतना ज़्यादा है. Just
Right.
to give a basic understanding of that.
Right.
So we can tell elements by that. And now we talk about phases of a star.
Mm-hmm.
So one nice analogy that we can give for planetary nebula, it looks like atom-centered nucleus
Yeah, that's what somebody was just
with
saying,
an
right?
electron cloud. Yes.
Yeah. The like everything is concentrated in the center and you have just circles around it. And I think we all, when we were growing up, had that one aha moment
Yeah.
when you realize that the atom and the solar system have
Similar.
there is so much similarity, and then you wonder if anyone has thought of that before.
Yeah, I felt like a genius at that point.
Yeah, man,
Just to have-
kids are easy to please.
Okay.
Yeah, continue.
Phases of a star. Now we talked about different mass ka, कि अलग-अलग masses है stars के.
Yeah.
How do we classify that? We'll just touch upon that थोड़ा सा. So mass of a sun that we know, we are going to take it as solar mass, and on that we are going to compare बाकी stars के masses.
Right.
So there are very low mass stars, there are low mass stars, intermediate mass stars, and massive stars. Now, what happens in a star? Athar, if you want to explain, you can go with it.
So basically, this is something like now the first part, like if we look at the low mass stars, so we classify them as less than 0.5 solar masses.
Yeah.
So if you have seen, like when we boil milk and like नीचे से आता है ऊपर and then it again goes नीचे and then ऊपर नीचे. So same thing happens over here.
Like because of the temperature difference.
Yes. So like gradient, the temperature gradient is there, and therefore it like the heat keeps on going. So
Got
like
it.
convection, or what you call it, convection or something, right? Convection, right?
Yeah.
Yes. So in the medium mass stars, there is something else. So like 0.5 to 1.5 solar masses. These stars are there are most of the stars are 0.5 to 1.5 that we can see. So like most of
0.5 to
them
1.5 is times
solar masses.
our sun mass.
Yes.
Yeah.
Times our sun mass.
So
So like
our sun is
relatively the similar mass of our sun,
Got it.
because they are stable and they are like they are in the main sequence, they are going and so on. So like there are many of it.
Got it.
So basically, center there takes place radiation, and around there is one called the Tacock line, the solar Tacock line. There is a concept of solar Tacock line. So there is sudden density change, and therefore that solar Tacock line is there, which regards in sudden density change, and from that towards the surface we see convection taking place.
Understood.
Now,
so the
interestingly,
smallest ones, the less than 0.5, they
low
don't
mass
have
stars.
this.
No, they don't have radiation. They have convection only.
Got it.
So this basically radiation is like fusion is taking in place over here inside, giving out, and then density drop, max drop, and then we get this.
Got it. I just
So
understood the third picture.
when we say that the sun is rotating, we take this as a solid ball inside.
Understood.
And the rest of it as gas going.
Right.
Type of, like, if you can imagine it that way. Like, that is the density difference.
Right. So
And
only the
interestingly-
central part which has the radiation, that is the one that is moving.
There's action happening there.
Yeah.
Fusion.
Action happening over there. And this is the convection part. So like recycled.
Understood.
Interestingly, opposite happens over here.
Yeah. How?
Convection under.
How is that possible?
So these are either blue supergiants or red supergiants or red giants. So like towards the end phase where they have almost synthesized all the helium from hydrogen. So they have exhausted their hydrogen fuel, and they start making they start fusing helium, and they get into the metal era. So like they start synthesizing metals, and therefore this happens. So like density change हो जाती है. So therefore there is this very interesting thing. जितना छोटा element fuse हो रहा है, so like hydrogen atom fuses, it needs some energy E to fuse. So like in the presence of that temperature, it fuses and gives away energy. As in when we go ahead, hydrogen to helium, helium to our size of our atom, our size of our molecule is increasing, and therefore we can say that much more energy is needed to fuse this. So like much greater conditions are needed for the fusion to happen.
Right. So that is why the bigger
rare.
ones are rarer.
Yes. So fusion becomes rare.
Yeah.
And there is a point to which it comes till silicon, and the time becomes very slow. So like for a star to exhaust all of its hydrogen, it takes many years. So like maximum time of the year, maximum time of its lifetime, it does only spend in exhausting the hydrogen it has.
Right.
Because some hydrogen gets fused in helium, some again come to hydrogen. There is a lot of proton chain and everything reactions happening over there. I don't want to get into that, but still. So like there is a lot of happening there. But when we step out of hydrogen from helium onwards, like from fusing helium, the process becomes faster. So much faster that when silicon is synthesized,
it takes a day.
If two molecules of silicon are synthesized, they fuse within a fraction of a second to get iron. And iron fuses and boom.
What is boom?
Explosion.
वो टूट जाता है ना, तो it collapses. is a large stage. So iron के आगे fusion नहीं होता.
Okay.
Oh my God.
Because so much energy is required that only few of them get fused, and so much energy is given out that it actually like breaks the gravitational barrier, the gravitational force acting on it to keep it in its shape. It breaks that much barrier, and then
so does it mean that all the elements till iron are covered?
Yes, in a star, yes.
Okay, I feel like seeing that atomic table again.
We can see that end में उसमें सारा दिया है.
Cool. Awesome.
Okay. So what we said about gravity and fusion not happening after iron. So normally what we see in stars is hydrogen हो रहा है. You can compress it to a point because they are not like strong metals yet, right? And so अंदर से fusion हो रहा है, so बाहर energy जा रही है, and then बाहर से gravity अंदर force कर रही है, right? So like I said, equilibrium है.
Right.
But when iron goes in, अब कुछ बाहर अंदर से energy नहीं जा रही बाहर. So it's just there. Now the gravity pushes everything with its force, and it either collapses depending on the mass. It collapses to form maybe a black hole. Or
a neutron star.
And the remains that जो बाहर उसकी surface पे दिखता है, it just goes out in the space.
So basically, actually there is a mass limit to which it can form a neutron star, it can form. So like there is a mass limit जिसके नीचे compulsorily white dwarf ही होंगे. It's a Chandrasekhar limit. 1.5 solar masses के नीचे सब white dwarfs.
मतलब white dwarf मतलब they will collapse into a
white dwarf. So वो HR diagram में जो the part where
low luminosity, low origin. Temperature.
Yes.
Yeah. Got it.
Yes, this one. So like this part, white dwarf area. This is a Chandrasekhar limit.
Wow. So our sun is definitely going to become a white dwarf.
Yes.
There's no way it will become a giant star or a supernova.
It will become a giant, and finally it will result in a giant.
Okay. It has to. Okay.
It has to become a red supergiant, blue supergiant, or a red giant.
Okay.
So
And
these
if
are,
any of that happens, we can't survive, right?
we
No,
can't
it will.
survive if it starts to exit the main sequence,
Yeah.
Okay. Good to know. Good to know.
because it will
Cool.
increase in size. It will keep on increasing size, and um, it will slowly capture.
Swallow. Yeah.
It will swallow Mercury first, then Venus,
Yeah. And
Earth.
then
then we
अपना
are
number
there.
है.
Yeah.
Wow.
So that's why everyone is thinking कि maybe Mars safe रहेगा उसमें.
Obviously
Maybe.
not. I mean, you're just going one step behind in the firing squad line.
Yeah.
What? How is that escaping?
I have no idea. That's why the entire idea of moving to Mars is so great for people. But
I mean,
yeah.
yeah, I guess
They
it
want to
could
go
buy
as far
us,
as from Sun
it could
and
buy
in
us
the
some
habitable
500
zone.
years more.
Yeah, that's it. Not more than that.
Yeah. But 500 years is a lot, though. I mean, in the last 500 years, our space technology has improved so much,
Yeah.
and
There was
technology
nothing.
improves exponentially.
It was nothing, and after 2000, there is actually US Space Force.
Yeah, I know.
Actually, US Space Force.
Yeah, I
Actually,
saw that. I saw the Space Force. I so you know what? When
What?
when I'm listening to all this, suddenly Elon Musk seems like the most important person on Earth. Just the idea of nobody else is talking about moving to Mars and taking it seriously. It's all science fiction.
Hmm.
Is there somebody else planning a
I
trip to
mean,
Mars?
Jeff Bezos.
Jeff
Yeah,
है.
Bezos का यार.
वो तो
These
आराम
are
से कर
not
लेगा.
these people are not planning. They are ready to fund.
Yeah.
Yeah.
Planning तो NASA and scientists कर रहे हैं.
Correct. No, but SpaceX is. I
Yeah,
mean,
yeah,
is
they
there
have
any
that.
other? Is there any other enterprise that is?
Yes, there is. So till SpaceX was there, NASA का कोई और था.
वो तो
I
फिर
don't remember the name.
रशियन रॉकेट्स यूज कर रहे थे ना तब तक.
नहीं, एक और था US. There is a super giant US guy
The
who did that.
Lockheed Martin वाला.
हाँ, yes, that guy.
Lockheed Martin, yeah.
He did all this stuff.
Yeah, because Elon wants to return to his home planet. Yeah, guys, like that's the old joke. That's the joke that.
Developing from Mars is going to be another task because वहाँ पे कुछ भी नहीं है.
Yeah.
And we have to build from scratch. So that's another thing.
Yeah, somebody was saying that. Yeah, you know who was saying Bezos will be providing prime delivery to Mars. I mean, only a matter of time. All of these are sequential events that will happen.
You're soon
Human
going to
sucks. एक खराब करो, दूसरी जगह शिफ्ट हो जाओ. Why?
Don't
We
you
are
think
going
it's
to-
easier to save Earth than to move to Mars? यार अगर
अरे, we are not saving Earth.
sun
The whole
trying
point of
to
moving
save.
to Mars is not depolluting Earth. The whole point of moving to Mars is because Mars is going to take a longer to get swallowed in sun, or maybe
yeah,
may
if the
not
sun
also
becomes a
swallow.
giant supernova, क्या plant करेंगे trees and yeah.
कहाँ
I
पे
mean-
ग्रेटा थनबर्ग उसमें नहीं है.
Climate crisis is never about even saving Earth. It's always about saving ourselves.
Yeah,
from
exactly.
हाँ,
what we-
वही तो.
There was a great stand-up show, I forgot by whom, that said that the Earth will be super happy once humans die.
Yeah.
Because, all the other species can thrive and climate change is only going to kill us.
Yeah.
All the sea creatures will be super happy.
They might just evolve very
Yeah,
easily.
I think it was Ricky Gervais. They said that there will be crabs floating on Mount Everest and saying, "Wow, I've never seen this view before. This is so cool."
But if crabs are floating on Mount Everest, then everything would be the same, right?
Yeah.
उधर भी
It'll be
पानी
just the
रहेगा.
water level.
Don't ruin the joke. Man.
Oh man.
Anyway, so yeah, these are the stars that we know, and this is our tiny, tiny sun.
Where is the sun?
It is there.
Hey, what a scam. What is this? This is such a matlab, here we are thinking that हमारा sun
This is not
super
scam
awesome.
1992. This is scam life.
अरे यार ये देखना पूरा औकात निकाल रहा है अपना भाई का.
This is Betelgeuse.
Yeah, this one. That's
Oh.
gonna explode.
All right.
On the verge of boom.
Just to put in perspective, that's अपना sun छोटू सा उसके बाद या solar
Yeah.
system किसके है.
Mhm.
That's the biggest known star, and then there's guys.
That is the biggest known star. You know, is Scooty. Scooty.
Hmm.
Yeah, Scooty.
Wow.
And then you
And
come to the warp seeking all this.
Wait, what? What is that?
Black hole.
black hole.
Holy crap.
That's the biggest known black hole.
That's the biggest known black hole.
Where is that and how far is that from us?
Well, it's very far away. Like I don't know
Located in
the.
the Perseus cluster, accounts for 5% of the mass in its host
Of its
galaxy.
host galaxy.
So, Abhi, if you are living in a galaxy which has a black hole like that,
We have a black hole. We have
We
a
have a
supermassive black hole.
Yeah.
oh yeah, we
At
have
the
our
center
own
of our
resident
galaxy.
black hole.
Every galaxy has a
अभी
supermassive
नोबेल
has a black
प्राइज
hole.
उसी को मिला था.
Oh, वो फोटो
अभी
जिसने
का
लिया
नोबेल
था
प्राइज
वो.
उसी को मिला है, राइनार्ड गेंजेल and that.
Right.
We have a supermassive black hole at the center of our. Every galaxy has to have a black hole at the center.
Why?
So we'll come to that. I'll
Oh,
tell you why.
wow, it's like a communication center. Do you think black holes are communicating with each other?
Dude, it feels like that. Honestly,
Yeah,
we
I
can
mean,
go
it's
to.
like there is a central communication unit, and all the galaxies can talk to each other. कि अच्छा ये black hole को phone लगा, and the black hole will communicate to the nebula, and the nebula will communicate to the sun, and the sun will communicate to Earth. It's like a.
There is a theory
I
like
am
that.
just
Like,
tripping on it, guys. None of this is scientific, okay? I'm
Yeah.
just tripping out here. Do not hold me responsible for stuff I say when I'm tripping. All right, continue.
okay, so I think we talked about this, like fusion, gravity,
Yeah,
and then helium, carbon, oxygen,
right.
oxygen, helium. ये सब चीजें we have talked, and then iron.
Yeah.
Now the iron, okay, we think कि oh ये iron पहले से और I don't know why we think कि Earth पे जो है वो universe में नहीं है. For some reason, right? So I have read this quote that the iron in your blood is capable of killing a star because the death of a star
I
happens.
didn't catch that. What?
The iron in your blood is capable of killing a
Hemoglobin
star.
complex is capable of killing a star because that's the last thing it synthesizes
Damn.
in its core.
So
And
the
done.
iron that we have is actually from that.
Yeah.
Yes.
If we go to the origins of the universe and things, the element.
And do you know that iron is considered to be one of the trickiest elements in the body
Really?
because there is iron deposition happening all the time. And one of the signs of aging is that we can't get rid of that iron.
Gerontology.
Yeah, so then the more iron gets deposited, the closer you are to dying. So we are all stardust, guys.
Yeah.
We are all
all.
stardust. We are all dying.
Yeah, somebody
Dying
have
like
said
how
that
stars
we are
are.
all stardust. So the particles in your left hand are from some star and the particles in your right hand are from some other star.
Yeah.
It may be,
Wow.
you just are made of stardust.
Oh man, this is so trippy. All right. Okay, go on.
So these are the elements on the periodic table, and you can see what led to the formation of that. Big Bang ka will talk aram se, but but then okay, so explosion of massive stars that causes the formation of these elements over here. Then white dwarfs के वजह से you can see कौन से elements बन रहे हैं. There's zinc.
In the ratio, in the like
Yeah.
itna.
इतना इधर से आ रहा है.
Okay.
And then
All right, wait. Let me just simplify. Hold on. Blue is Big Bang. So that is hydrogen and helium.
yeah.
Then you have
No,
some
helium has some part
Yeah, helium
related to
has
the
some-
low mass and expanding massive stars also.
Correct. But on the whole, like majority. And then you have some elements of pink, blue, and yellow, which is dying low mass stars, exploding white dwarfs, and cosmic ray fusion. And then as you go forward, you get more of green, which is exploding massive stars. And then towards the end, it's all orange, yellow. which
Oh.
is merging neutron
Merging
stars,
neutron
dying. All right, okay.
So tell me one thing, what is the source of this image?
What do you mean?
Source like किधर से लिया ये?
Internet?
Because Big Bang Fusion के इधर they have given cosmic microwave background का picture.
Let's just, yeah, it's
Okay.
understandable.
All right.
Okay, anyway, so I want to talk about neutron stars a
Why is
bit.
technetium and what is PM? Permethium. What is that?
Permethium.
That's
Yeah.
permethium, right?
Yeah, yeah.
Yes.
Oh man, my memory is awesome. Okay, so why are they in gray?
You're a doctor, it has to be awesome.
But I don't have to remember permethium. I'm not trying to create what is that, adamantium or something. Okay, so why are they in gray?
Well, they are, I guess, probably like created outside of these
Really?
action.
Wow.
So,
Due to some chemical reaction, I don't know.
like we can,
Why?
I guess, create them out of it. अपने इधर से खुद से. I don't like chemistry, so I don't know.
Okay.
So,
Chat. If anybody knows, can you tell me if what is separately special about technetium and permethium?
yeah.
Atomic number 43 and 61. What's with that?
Till then, we'll talk about neutron stars.
Sujit Rai has said she seems cool. Okay, Sujit. I mean, for
तेरे लिए 100 रुपए.
Wait, मेरे लिए?
हाँ.
That is my market value. Okay.
No. It's just
No, I
somebody super
appreciate
chat.
it.
Sid is
Yeah.
just fascinated by colors more than anything. Yeah, I mean, that's just the one thing I understand out of all of this. All right.
Okay.
Go
So
on.
if you see, यहाँ पे आधे से ज़्यादा heavy elements जो है ना,
Mm-hmm.
they are formed in merging neutron stars
Mm-hmm.
or dying low mass stars.
Hmm.
Okay. So neutron stars are very interesting because let's just say a neutron star, okay, it's 24 kilometer wide. वो इतना dense होगा कि उसके 1 cubic centimeter में अभी तक जितने भी इंसान थे उन सबका weight you can put in. It's that heavy.
Yeah.
And if the star was more bigger, then it could have just become a black hole itself.
Yeah, I've heard
So
of this. Like 1 teaspoon of a neutron star can contain the mass of an entire solar system or something like that. I don't know.
Yeah, it's like
Much more,
Everest in a coffee.
much bigger than that, I guess.
Oh,
No.
really? Wow. Okay. No, I mean,
Yeah.
I was already in awe and then you just added some more awe on top of it.
So yeah, I mean
Akshay, thank you so much, Akshay. Yeah,
Oh.
tell.
from what I have read, that it's equivalent to coffee ke mug mein a Mount Everest. So
Wow.
yeah, they're very heavy,
Yeah.
and surprisingly they spin very fast.
Mm-hmm.
They are called celestial ballerinas.
Wow, I love that
And-
word.
They spin like multiple times in just 1 second, and like you can hear their pulse going around.
You can actually type on YouTube
Huh.
pulsar sounds
Hmm.
and then just listen to it. Like some of the
I'm pretty sure it'll be
medium-
full of bike rides.
No, it's periodic. These are much more. These are like these are so accurate. These are accurate than the atomic clocks.
Okay.
It's like sonography में जब heartbeat सुनाई देता है, I guess. It's something like you can hear that pulse in it.
Wow.
It's
For each given different frequency, obviously,
yeah.
there are something you can just hear a beep because it's so much high frequency that you can't see the periodic nature of that star.
And so, what are the pulsar stars? What are they?
Neutron stars.
They're neutron
Neutron
stars.
stars.
And
Yeah.
neutron stars will end up creating what?
No, they have.
They just
They just are.
yeah. And so if they were heavy, like they were formed from a heavier star, then they would have been a black hole. But
Hmm.
they are a consequences of a bigger star than our sun.
Somebody had just asked an interesting question
Hmm.
that, but there's no sound in the universe.
Hmm.
How can we hear a star?
Frequency.
Yeah.
So like we don't actually hear the sound. So we see there is a lighthouse. There is a lighthouse near a the seashore,
Yeah.
and the huge halogen or something like that light is just roaming.
Yeah, correct.
So, okay, so like if it is making five rotations per minute per second, if it is making 5 revolutions per second, then we calculate the frequency, and we associate again. We want to
We
see
just
how it
convert
looks
that
like.
frequency into sound.
Yeah, we just see that is frequency sound का क्या है, then we say
Right.
that oh,
Interesting, because it's all mathematics at the end of it.
Yeah.
Yeah.
yes,
And as soon as we say rhythmic,
Mm-hmm.
we are sort of in the sound territory. We are in the
we want to feel the rhythms.
Yeah.
So like we want to feel the periodicity of a particular phenomenon.
brilliant, brilliant. I want to ask you if there's if astrophysics has found Ohm in the universe.
What?
No.
Yeah.
Like
Yeah, like the
yeah,
space sounds like, oh. Yeah.
it was a question that's come up so many times on my chat that I thought I'll just make
So-
people happy.
I mean, I don't know if it's like Ohm or not. It's basically our pattern recognition.
Yeah,
or
exactly. That's what even I thought that. But I have heard of the cosmic sound that there is a frequency, there is a repeated frequency in which a lot of stars seem to be spinning at, and
No,
like
there
people
are
are finding same
many other
numbers.
frequencies. There are much like there is a vast again a spectrum of frequencies. So like we can't associate a certain frequency
Right.
to be the optimum one.
Okay.
So like it depends on what sounds good to our ears, right? Which frequency is better suited for our ears, which is a calming, maybe like has some psychological effect.
Yeah. Also depends
We
on
tend to associate that to be the optimum,
Yeah.
but scientifically we can't say which is the optimum
correct.
frequency.
And what you said, right, about it all depends on if you're looking for it. So there is a lot of confirmation bias there.
Yes.
Exactly.
Yeah. If you're looking for a particular frequency, it's likely that you will find it.
Hmm.
Okay.
So
Go on.
yeah, so neutron stars are interesting mostly because we don't know what happens in uske core mein. Because just everything is pushed to such a point that हमें पता नहीं अंदर कौन सा matter form हो रहा है. There is a theory that there is strange matter inside of it, and if that is true, that is the most dangerous thing out there, because if it touches anything, it will convert it into that strange matter.
Wait,
Kind of
what?
like, yeah. It's
What are we even talking about here? What is this?
No, what? Wait.
so strange matter. We still don't know the exact properties of that. I read a paper recently on that,
Uh-huh.
and they were talking.
There is something in the subatomic particles also that was called strange.
Strange quark.
Yeah,
Yeah.
is that the same thing?
It is somewhat related,
No.
but not
It is
entirely.
like-
Yeah.
Maybe related. I don't know. I don't
Yeah.
have any knowledge on that.
Okay. So as far as we know, there is something else called a strange matter.
It might be.
It might
We
be
don't know.
in the middle of a neutron star,
At the core,
at
yeah.
the core of a neutron
At the core
star.
of the neutron star. So like something has to happen, right, in a neutron star that
Yeah.
will keep the shape intact. That
Yeah.
will balance the gravitational
Damn.
interaction.
But just like brown dwarfs, हमें नहीं पता क्या चल रहा है अंदर. That is
Amazing.
keeping it together.
All right. Lovely.
yeah.
So many things
Yeah.
we don't know. I love it.
Yeah, we're just gonna find out soon that could be, yeah, never mind.
Yeah, but that's true. And to be very honest, if that's when you know that you are reaching the not the depths, but at least you're getting somewhere in your pursuit of knowledge in that particular subject. Once we get to questions that don't have answers.
Yeah.
Because if
Yes.
everything that you're reading has perfectly formed explanations, then you have not gone deep enough.
Yeah.
In any field, it doesn't matter whether it's archaeology or neuroscience or maths or whatever, medicine. As long as all your questions are answered perfectly, it means you are just scratching the surface, and you will feel very good. But is that the point? are you in it for happiness or are you in it for growth? So
Yeah.
you should dig until you run out of answers.
There should be a T-shirt. Are you in it for happiness or are you in it?
Yeah. So all of our streams
Tidki Moritz. Tidki
come
Moritz.
out with some merch idea. I hope somebody's making note of all this, but yeah, anyway.
Yeah.
Okay, next.
Okay. Now, second innings. We have talked about this. Now, it's the basic life cycle. So we'll just look at हम लोगों ने क्या क्या बात
Second
किया.
innings is like fate of a star basically.
Yeah.
Right.
So stellar nebula है, and then average star, massive star, red
Yeah.
giant और red super giant. Planetary nebula बनेगा या फिर supernova होगा.
Right.
Planetary nebula से सिर्फ white dwarf बचेगा जो बीच में रहता है.
Right.
और supernova से there is a neutron star or a black hole.
So
now
our
we're-
sun is an average star.
Yeah.
Yeah.
Uh,
And so yeah, got it.
It would just go to the red giant phase and then
Yeah. And
फटेगा.
then when it becomes old, it will form a planetary nebula.
Yeah.
And yeah.
Then a white dwarf.
Yeah.
So we have understood this so far. We know why the sun का explosion and implosion क्यों हो रहा है, right?
Right.
Stars का.
Right.
Now we are going to talk about black holes.
Oh wow. Okay. And so this is the last section of the talk.
Yeah, in a way.
Beautiful.
In a way.
In a way.
No, not actually, but yeah, okay.
Yeah.
Alright. Tell me.
So
But you want to end it?
No, I'm good. I really want to talk about black holes. I don't want to end it without talking
No,
about it.
after black hole. Okay.
After black
Let's
holes,
see.
we will see how
Yeah.
it's going.
Okay.
Yeah?
We will have to end it somewhere, right? Or
I mean, yeah, before the sun converts to a
Oh.
giant, we have stuff to do.
Nerd. Okay.
Alright, tell me about black holes.
Okay. So before we understand black holes क्या है and everything, we got to understand what is space-time and gravity and ये सब चीजें.
Okay. Yeah, like the basic stuff that everyone should know.
Yeah.
Yeah.
So there is a very common example of a trampoline and उसके अंदर अगर एक object रखा, it
Yeah.
will create a dip,
Yeah.
right? So Einstein explained the existence of gravity that way. He's like, gravity force नहीं है. It is just a consequence of having mass in this fabric. Okay. You have mass, you create
so
a
there is
dip.
a space-time fabric, and if object sits there, it curves the space-time fabric according to its mass.
Wait.
And that is something of a concept of gravity, basically. That thing.
So, guys, chat, if you haven't seen that video, there are 3-4 videos of some different people showing that.
Yeah.
A trampoline, they put a cannonball, I think, in the center, or a bowling ball
Bowling
in
ball.
the
Yeah.
center, so that the whole thing dips down, and then they take marbles and they just rotate it around the side, and so you can see it going round and round. And the reason it's going round around the bowling ball is because of the weight of the bowling ball.
Yeah.
So it's a very nice video. It really changes the way you look at gravity. So I would suggest that you all go and check that out.
Okay. So now we have the basic understanding कि gravity क्या है. It's not a force, ऐसा खींचा खींची कुछ नहीं होता. Just a consequence of having mass. Let's ignore that. Now this is the first picture of the black hole we have ever taken. Over the years, you can see it move. See. And it is interesting how we took it in the first place, because light cannot escape black hole.
Yeah.
Right. And yet we see a ring of light,
Yeah.
and there's a lot going on over there.
Yeah.
And we have captured it. We have captured the unseeable.
Yeah. How is that?
So it's basically, there is a radius. So a black hole में ऐसा नहीं है कि if you go anywhere near it थोड़ा भी तो सब अंदर चला जाएगा, or it sucks everything in. there is a structure to it. There are we'll talk about it आगे.
Okay, sure.
And but I'm just showing this कि ये हमारे पास picture है.
Yeah.
Now this is the space-time curve
Yeah.
that we see, and when you see light, you can see that it bends because of this curve,
Correct.
right? So light as a path change नहीं करता. It is like surfing on space-time का waves. It just goes wherever it goes, and since there is a bend,
Light
it
also
bends.
bends.
Yeah.
Yeah.
And you can see that अभी ये mass है, so see how space-time is bending. This is
So basically, it's not a 2D fabric. We visualize it as a 2D fabric because like it's easier to tell citizens what it is exactly.
Yeah.
So, but it is this is a simulation. So this is 3D space-time fabric basically.
Yeah.
Or
What is
can you
weird
call
is
it?
light will bend because space-time is bending.
Yeah.
And so for us, it is a straight line.
Apparent position.
Yeah, because...
So what do we do is we extrapolate our vision, draw tangent and see, okay, इधर रहना चाहिए.
No, but how can you draw a tangent in space-time which itself is bent?
No, that's why that's apparent thing, right? So like we
So
say that this light is coming.
Bending is from a third person's perspective. We will always see it as a straight line.
Yes. But we know it's bending because it has to. Relativity.
It's like throwing a dart in the dark.
God damn it.
Yeah. So see, now there is a mass.
Wait, how is it like throwing a dart?
In the dark.
Oh, in the dark. Okay. Yeah. Got it.
So this is the bend. You see that ये bend हो रहा है light.
Yeah.
And this phenomena we called it gravitational lensing.
Lensing. Oh.
Yeah.
Yes.
So this is where the distant galaxy is. But since there is this बहुत बड़ा cluster है, बहुत ज़्यादा mass है, so it just bends and you see इधर या फिर इधर virtual image of the
And
galaxy.
this galaxy cluster
This is
of
exactly
importance.
like the eye.
Yeah. I mean, we are seeing it through the eye.
Oh
Yes,
my
but-
God. Okay, I'm tripping. So when in the eye, so imagine that the cluster of galaxies is so our eyes have lens and the object is in front of us and the lens will converge the light and make it fall onto the retina.
Yeah.
So here retina is Earth and cluster of galaxies is the lens. And
So basically this is a big fat lens which is causing the refraction that we see in eye, but it is not refraction. Basically it is a kind of refraction, but it is not due to the change in medium. It is due to the space-time curve. It is due to gravity that it is changing.
Okay.
So type of this.
This is what it actually, this is like a real picture. And ये जो, when you see this galaxy is bent, like पूरा stretch out हो गया है. So it means that these stars are so heavy that पीछे के जो galaxies है, they're gonna just like.
Or maybe this is a elliptical galaxy. This is a galaxy cluster, and so this is a elliptical galaxy, and due to that, so this galaxy cluster is in the foreground for us, and that is in the background. Those bended galaxies type of.
Yeah.
So like they are. This one may be irregular. This one may be a spiral, anything. So like galaxy morphology ke hisab se this can be anything. But this is a elliptical galaxy which is causing the gravitational lensing of the background for us.
And this is what it looks like. And
foreground mein hai ye cluster. That is the background which is getting lensed due to the foreground.
Understood.
This is the lens.
Yeah.
So basically this acts like a lens, refracting lens, which is giving us apparent images of the background.
Yeah.
Okay, got it. I think that's clear. Hang on. Chat, are you with this so far? Are you
Goosebumps in
this
200.
looks like एक और wallpaper material. I agree, Stuti. Goosebumps 100 times. Yes, Abhishek. Ankit Patel, thank you for the super chat. Will it be correct to say whatever elements present in my body has come from the Big Bang explosion?
Yeah.
Or these elements were in celestial space at some point of time?
But why are we assuming Big Bang explosion?
Yeah, like
Why do we
whatever
want to-
created the universe, whatever
Yeah.
is in the universe,
Yes.
is made up of that.
Yeah,
Simple.
I think so. Yeah, at some point we were all in
Not
outer
creation,
space.
but okay.
What?
Yeah.
Not
Yeah.
creation exactly, but still it's like the problem with Big Bang is like you can extrapolate everything for the future, but if you want to say that if you want to think that why did it happen, then you can't backtrace it for
Yeah.
a single point.
Hmm.
So that is one big flaw. So that's why there is a theory which says that it is expanding, contracting, like in a
Yeah, like a waveform.
periodic way, periodic nature. The universe expands then contracts, expands and contracts.
Hmm.
That is one theory, which I think is better than Big Bang, but okay, still.
Yeah.
So it doesn't originate from a point. It just goes to some minimum distance, minimum size, and then again.
Hmm. So that
But
minimum
then
size is
उसका start कैसे-
relative.
Yeah.
Yeah.
So that theory actually is repeated across multiple ways.
Yes.
Even a lot of mythology talks of it, which for me
Yeah.
is very interesting.
Reincarnation and
No,
all
no,
that.
not reincarnation.
No, not reincarnation.
The cycle of the universe.
Yeah.
Uh-huh.
There are verses in Bhagavad Gita that have it like written down that how many cycles has it undergone, and how after every cycle.
But it
everything
still doesn't
collapses.
have any theoretical base.
Yeah, it
It's
doesn't.
just-
It doesn't.
Yeah.
Yeah, that's why.
Yeah.
So basically, this was the singularity theory was like the Stephen Hawking gave that, and then a PhD thesis, and then he contradicted his own theory, PhD thesis in his postdoc by giving the black hole radiation. So like black hole
Hawking
radiates,
Yeah.
it gives out radiation, Hawking radiation.
Okay.
Yeah.
All right.
So now we have understood gravitational lensing, mass कैसे affect करता है light को, the bending of space and time. Now we're going to talk about time.
Okay.
Now let's just look at these points.
Mm-hmm.
ये एक ही लाइन में है, but
Yeah.
as space changes, हर एक point अलग-अलग time पे time experience कर रहा है.
Yeah.
So that is the general like relativity wala concept.
Right.
Like yes, it's just a very basic understanding of that.
Beautiful diagram. Beautiful, Jeff. Loved it.
Yeah.
So see this thing.
Ashwin,
They have mentioned the
welcome. Welcome
velocity.
back to the chat. Huh.
Velocity with respect to c, which is the
Yeah.
speed of light.
Yeah.
So these are comparable velocities, and that's why we can see this.
Huh.
Yeah. It's
But
like
if the
relative.
v by c ratio gets far less than 1, then we consider c to be infinite with respect to v. So like we don't even consider c.
Hmm. Got it. I think I got it.
Okay.
So one of the recent interesting things I had read about time was in that hypergraph theory about how so time is just equations taking place, and so
Oh yes, this is mentioned in the hyperspace book of a space-time Odyssey or something by Michio Kaku.
I don't know about that. I read about it in Wolfram's paper.
Okay.
Oh, okay.
Stephen Wolfram's paper on the hypergraph theory, and the idea of how time itself does not exist, but there is a constant exponential equation happening from, I mean, whatever you can say, Big Bang or whatever, but and it is that recurring algorithm that is constantly running. And
Okay.
every algorithm initially is very simple, but then if it's exponential, it very quickly evolves into very high degrees of complexity. And time is basically that equation running to the next step. So, okay, this is super meta and completely away from astrophysics. We will discuss this at some point. I would love to have a discussion on time and just physics. Maybe after I do a discussion on neuroscience of time, I would love to hear it from the physics perspective. So, yeah, we can do that some other day. All right, go on.
So the 2D fabric of space and time, this is not what it looks like, but just for example. So sun hai, it bends space itnu sahi. There is a white dwarf, which bends space itna. The neutron star, which is...
Oh my god, it's like it's dug a hole in space-time.
Exactly.
And then imagine a black hole.
Like,
this is the event horizon after which the radius is...
It just goes to 1 point.
1 point. Singularity. This is a singularity. The bottommost point.
It's like, how do I say it? So there is a certain point after which, if a thing crosses that radius,
Schwarzschild radius.
Yeah, it's going to be a black hole. So I had it in the first thing. So let's say human 70 kilograms ka hai. There is a formula for...
I feel attacked, but okay. Continue.
So the radius...
What kind of judgment is that?
Just
humans can weigh more, okay? It's completely fine. Chat, do not believe this table.
It's a hypothetical table.
Yeah, but add 20 kgs to all of the above, okay? The Milky Way is clearly 1.6 into 10 raised to 42 plus 20 kg. Okay, sorry.
It's okay. So, the radius, Schwarzschild radius, I guess. That is how you say it.
No. I thought it was like, no.
How do you say it?
No. Yeah, you're saying it right, though. Your moderator just mentioned it wrong in the chat.
What?
The spelling.
The first part of which was streamed 1 million years ago. Okay, no. Karthik, how does space-time relate to gravity? I think we are covering that, Karthik.
Mass.
Schwarzschild. Okay, Ashmit, spelling and stuff. Okay. Yeah.
Cool. So this radius is the radius after you have this formula. Okay, you know mass kya hai. You know the gravitational constant, the speed of light, cos square, and then 2.
Yeah.
Now you put that in, you get a radius beyond which if you try and shrink anything, it's going to be a black hole.
Oh.
So if you shrink yourself to this point, then you'll be a black hole. If you yourself.
Let's take a better, imaginable example.
1
if
into
you
10
shrink
raised to
sun,
minus 25. So that is what?
Not very far. Don't even think.
Minus 25 is an atom.
Not even there. No.
It's
Much less.
Much lesser than an atom.
Atom is of a dimensions of angstroms.
Yeah.
Like 10 raised to minus 10 or something like that, or 10 raised to minus 9.
Oh.
This is 10 raised to minus. See a very relative example. If you shrink sun to the mass of this mass to this radius, so basically the city of Manhattan.
Yeah.
Then it is a black hole. City of Manhattan in your
if you shrink
Brooklyn,
the
right?
sun
Brooklyn, Manhattan.
Okay, sun into Manhattan will be a black hole.
Yes.
Okay.
With that same mass density, utni kare to.
Utni rahegi.
Got it. Sukriti group. Oh, Sukriti. I didn't know you were a member, Sukriti. So cool. All right. This is the closest I've got to becoming a medical student. Okay. This is not medical. There is nothing medical. It's making us feel medical. We are losing our minds a little bit. But yeah. Anyway, welcome.
What is this? Welcome to medical students. What is this? I didn't get it.
No. So I have a medical students membership.
Oh, okay.
So yeah, Sukriti just became a medical student. All right.
Oh, okay.
Go on.
All right. So we know the formula, like the minimum point after which you'll be a black hole.
Yeah.
Okay.
Yeah.
So that point, like, it can help us determine the event horizon,
Yeah.
a radius as well. Okay.
Yeah.
So the event horizon is, now this is a black hole. It doesn't, it looks like this because हम लोग उसे perpendicularly देख रहे हैं, like interstellar वाला black hole है ये. Okay. I'm gonna try and
Gargantua.
क्या?
Gargantua ऐसा ही कुछ था ना?
क्या पता. So anyway, now do you see this? Okay. अब ये जो matter है, like this light is a cause of matter falling into the black hole. Like it's getting dragged by the gravity.
Right.
And that gravity is like इतना बड़ा drag है कि energy release हो रहा है. And that's why you see the light. It's radiating that falling, the action of falling into the black hole.
So the mass which is going into the black hole is emitting light.
Yeah, because it's getting dragged to that point.
It is rotating around. It is revolving around the event horizon. So like its speed is increasing.
Right.
And so a mass, an object can only cross the event horizon into a black hole if it has a speed greater than light.
Which is not possible.
Because then, if it has a speed greater than light, then it will be like nothing, right? If we won't see anything. That's why if it has to cross the event horizon, it has to exceed the speed of light. And as you go near the speed of light, this matter starts like radiating, and also it's like expanding.
Oh,
it's stretching out.
Disintegrate हो जाता है पूरा वो into small particles.
And so all its energy will just get converted to light, and it gets emitted.
Yeah.
Yeah.
Not all, but
I mean,
it will
some
radiate.
of it,
It will radiate.
Correct.
You see it that way.
It's
There
like
is some radiation.
It's like a dying, help me kind of. Wow.
You know, you can say that.
Wow.
So this event horizon. So if you are outside of this event horizon, up safe ho. If you fall into it, gaya. So now what happens
Not
is,
still safe, but okay, you're not intact, but
yeah, you're like getting dragged towards it.
Right.
But let's just say ki safe hai. It's better than dying inside a black hole. So
you will be dead by then itself, disintegrated.
Guys, let's keep it optimistic, guys. Let's keep it cheerful.
yeah,
We'll be on that cool light thing. It's cool.
Yeah.
It's fine.
so now event horizon हुआ. Even like अब let's just say कि ये point है singularity का, not even singularity, the radius, event horizon का जो radius है, there is an inner radius of that as well कि जिसमें the matter is circling down,
Yeah.
right?
Yeah.
तो उसका जो radius है, now let's just say उससे if you are 2.1 swirl radius के हिसाब से away from the center,
Yeah.
then if the light goes on that distance of the ring, then the light will just make one round and it will escape to the infinite point. Like it just flows away.
Oh wow. Is it like that sling thing that they did in Interstellar?
Yes.
Yeah.
I mean,
Yeah, sort of.
Because of that gravity, it just loops around it and then just gets flung
It just goes.
somewhere.
Yes.
Yeah.
So it's like that firework concept.
Chakri.
Yeah, chakri. It's
Yeah.
matlab the light will escape in that system.
Tangent में निकल
Yeah, in
जाता है
different
बाद.
tangents.
Yeah.
So cool. All right.
So wait, I had made some notes on this. Now
We are all attracted towards the black hole. I mean, that's from a physics perspective, that's very accurate. Sukriti, I mean the membership. Oh, you mean the membership? Okay. Wait, Sukriti, are you a medical student?
Yes.
Otherwise, I mean, that's super cool of you that you took a medical student membership. Okay, tell me.
okay. Now how we took the photo. Now why does it look like this? Is mostly because light का movement. Now, at what distance are you? उसका किधर से light आ रहा है? It depends on that as well.
Yeah.
So if you look from above, it's just gonna be like the one we see, this one. ऐसा दिखेगा.
Right.
And then you see इधर निकल रहा है चीज़ें. That is the thing escaping.
Oh, yeah.
Relativistic jets. Jets.
Okay.
And so why we see it like this is not उसका ऐसा exterior band नहीं है. It is just because how at what angle we are perceiving it from. So light नीचे का light reflect like घूम के वापस नीचे दिखता है हमें और ऊपर का it just
There is a nice video how to make this. Like
yeah. And there is a video by Vertasium.
Vertasium. That's the video I'm talking about.
Okay, what's it called? One of the mods can put it in the link if possible.
Understanding the picture of the black hole.
Black hole.
Okay.
Vertasium.
Vertasium. Okay. If someone can find that, just put it in the chat.
Yeah.
Sujitra has just sent, what is meaning of singularity in astrophysics? How is it different from meaning of singularity in terms of artificial intelligence?
First of all, what is singularity in artificial intelligence?
I think that moment where artificial intelligence becomes self-conscious.
No, so this is not the point. So this is where everything boils down to one point. So like time becomes no time. Like
there's no time.
Stop.
There's no time. There's no space also.
The time stops.
Time stops.
So like we cannot like it is not intelligent enough to comment about the space because like it doesn't make sense. Everything makes sense according to time. So
it's
like
love,
time
guys.
stops.
It's love. Time stops in love. Okay. Singularity is all about that.
Yeah.
All right.
So this is the picture that we took of the black hole. And what we did is we just knew हमें पता है कि इधर ये जो cluster है. So it's from a nearby galaxy, M87, and it is from our Virgo cluster itself. And यहाँ पे we knew कि वहाँ पे black hole है because we observed the stars around that area.
Yeah.
And we saw how they move. And उसके हिसाब से. Now we know कि कौन से point पे light रहता है, दिखता है हमें. And कौन से point पे नहीं दिखता है. So we just mapped all of that, and 8 telescopes on Earth worked together to take this picture.
Wow.
And
it has cost
corners.
Billions of dollars.
Yeah. Different corners of Earth.
One picture cost billions of dollars.
So this is like the most expensive photo.
Yeah.
Absolutely.
Probably.
And उसका data इतना था कि उन्हें planes पे भेजना पड़ रहा था सारा data.
Wow.
In hard disk, like petabyte के hard disks में, like can you imagine?
And it's been collecting over a decade.
Since 2010, I guess, right?
Yeah.
And now people are going to share this on Discord and put it as their wallpaper.
I have seen like Pikachu meme on this as well.
Oh wow, amazing.
So that's a black hole. Now there are problems that arise with it. Just ignore that. I am probably gonna stop sharing, or I'll just keep it to this. Let's just keep it here. Now black hole में problems है. It does not make sense. We don't know what happens to information once it goes inside of it. Hawking radiation is, let's just say, it says that the black hole loses its mass over a period of time.
Right.
Now that time is, I have noted it down. So after 10,000 billion years, it will lose 0.0000001% of its mass.
तूने 2-3 जीरो इधर-उधर कर दिया तो फर्क नहीं पड़ता.
नहीं, what will lose its mass?
Black hole.
The black hole. That is the Hawking radiation.
Okay, so that's how long it takes to die. Like it will not die.
It will die.
But not in our lifetime.
Not in anybody's life.
Yeah, I mean. Okay. So it's going to outlast most of the stars.
Yeah.
Yes.
Right?
So basically, it's saying like you are in Rajasthan desert, and then you are just taking some grains. So like you are taking a pinch of sand
Yeah.
each day and depositing in it, suppose like some different city. So like let's say like Delhi,
Mm-hmm.
and then it would take so many years to just transfer that sand, pinch by pinch, one day at a time,
Yeah.
Yeah.
or 1 year at a time, or something like that.
And
I don't
there's
think we have any human examples to really capture the magnitude of this thing. Like in,
No,
yeah, like I don't
we are
think we
not even
can.
sure of the theoretical examples like ratio. We are,
Yeah.
we are actually,
Yeah.
but like,
Because one of the pitfalls of human conception, because the way we conceive of things is that we try to correlate it with things that we know.
Hmm.
And if it is outside of that spectrum, what I told you about awe,
Yeah.
there is a spectrum to which we can grasp. Beyond that, it's just numbers. Like it has no emotional value. It has no. We can't wrap our heads around
Fathom
it.
it. Yeah.
Yeah, I mean,
absolutely, we can't.
It's like we can't picturize what 1 billion is. So I read this somewhere that 1 billion seconds is 31 or 35 years. That is how 1 billion is big.
Yeah.
So
Yeah, we don't, maybe because we are not used to it also.
yeah,
But
No, but how would we be used to it if our scales are so small?
yeah, correct. No, nobody's going to say in an interview, where do you see yourself in 1 billion seconds? That's
Yeah.
not the scale that we use. So,
And
exactly.
that's pretty dumb to say. Simplify and say that's it.
yeah,
Otherwise, say where would you be in 10 raised to 9 seconds? They use the
correct.
what you call that scientific notation,
Yeah.
something like that. Why?
Yeah.
Okay.
So
So, what
now
are the
that
other problems with black holes?
we'll
Somebody said
just
black holes need a therapist, but okay. I don't know what to do with that comment really.
we'll just yeah, give attention to that. Anyway, so black holes, what happened?
Nothing. Continue.
Okay, so black holes mein something very interesting happens at the event horizon, that when a particle, let's say, what's happening?
तुम ब्लैक होल ढूंढो, मैं ब्लैक होल ढूंढता हूँ, तुम ड्रीम 11 पे टीम बना लो.
Wow, okay. Anyway, so event horizon pe what happens is, let's just say matter जा रहा है कोई, okay, it splits. Half of it escapes and half of it falls in. That is what happens at the event horizon. Now that is interesting because we don't know what happens inside a black hole.
Right.
Everyone thinks that, so how people in this field define information is just, let's just say, arrangement of particles is what information is. It's same particles. If arranged differently, it's a banana.
Yeah.
If arranged differently, it's a squirrel somehow.
It's topology, everything is
Brilliant.
Yeah. So just, yeah, that information is lost forever. That is what people think, because we still don't know what happens inside a black hole at such extreme conditions.
Right.
So there is one theory that says that when the matter at the event horizon splits, right? So जो matter escape कर रहा है ना, it not the matter escape, जो अंदर जा रहा है, somehow black hole absorbs the information. This is a complete
hypothetical scenario where the black hole absorbs that information.
Yeah.
Just random person sitting and thinking, what if?
No. There's like a paper on this.
Obviously.
Yeah.
But like, what if?
What ifs are always good, man.
Yeah. So
there is no math.
What is the conclusion from this?
Yeah. So I'm getting there. So so people think yo black hole अगर end universe के end तक सिर्फ black hole ही रहने वाला, universe will be deleted because सब information गायब हो गया, right? But there is a theory कि black hole के event horizon पे the 3D information of that particle is encoded at a 2D level. It's like a storehouse.
Mm-hmm.
And the particle that is escaping, um, it gets that information.
Right.
Yeah. So this brings up the theory of universe being a hologram because 2D data is being projected as 3D. Like 3D में convert हो रहा है. That is what a hologram is.
So everything is a simulation.
Yeah. That is where this theory comes from.
All right, guys, we are wrapping up. Everything is a simulation.
Yeah.
सुपर चैट दो मत दो, कुछ फर्क नहीं पड़ता.
सब मोह माया है.
सब we can't say Momaya anymore. सब
Yeah.
escaping information from black hole का ring light है. Wow.
I mean, yeah.
No, so
So these are the things which we talk, like we once we say that there are time crystals, time has internal dimensions, and then we say that there is some point in the universe where time stops. Like,
yeah.
Yeah.
what is it? The origin of time 0,0,0, or is it the fate of time, like asymptotical? What is it like? Nothing.
So if every galaxy has a black hole, then can we assume that I mean, we can't assume it, obviously, that'll be ridiculous. But is it possible that all the mass in that galaxy may have at some point escaped from that black hole? Because, I mean,
So
they could have-
basically, it doesn't escape out. It escapes. It goes in.
yeah,
so like
but then
it
half of
escapes
it will
from the
go
galaxy.
in, half of it will go in, and half of it might not.
It splits.
It will disintegrate and go in. It the object or matter escaping the event horizon is going inside the black hole. So like it's not coming out, it is going inside the black hole. That is escaping the event horizon. It is passing that barrier to go inside.
Got it. God damn it. I mean, a topic like this is just open field, like open territory for hypothetical situations, because you can't prove anything to be wrong.
Not till now. If we have a unified model for a universe, then we can.
Yeah.
But we need that unified model. That's what Stephen Hawking said. Like, why don't you believe in God? He said that because I believe in one equation, the unified equation which explains all the universe.
But that doesn't
And
exist.
then somebody asked that, does it exist? He says no. He said that somebody asked like, what is the answer to it? What is the solution to it? So he said that that's the important question.
Yeah, exactly. So the idea for a one perfect equation is also our need for pattern recognition.
Yeah.
Because
Our need of explaining everything and letting people know that, oh, we know everything.
yeah,
We
it
know
gives
the
us a
theory of
sense of
everything.
control.
Survival के लिए भी it's helpful, right? The more we know, the more it is.
Yeah.
Better.
And at the end of the day, it comes down to our limbic system telling us, okay, now you are safe.
Yeah.
That's what all of this is about. This need to know what is inside a black hole comes down to our amygdala telling us, okay, now that you know this, you might be a little
What's
safe.
next?
Yeah.
There is always what's next.
Yeah, there's always something else. There's always something more.
Thankfully.
Okay. What's next after a black hole?
So we want galaxies,
Yeah.
galaxy morphologies. Then we want their interaction. So like
Okay,
this.
insanely good PPT.
Yes.
I have to say, everybody, seriously, Meenal, you made this?
Yeah.
Mainly yes.
Okay, Meenal OP, Atharva OP, PPT OP, I don't
Athar
know.
helped me with it.
Help you, okay. Can we all just have a shout out for the PPT? I mean, come on, this is great stuff. Amazing stuff. Okay.
Oh, this makes me so happy. Okay.
No, really, really cool.
So we have galaxies, then we have galaxy clusters,
Okay.
and then we see that what's missing. Something is missing.
Right.
Not something. Almost all is missing.
Everything
We
is
have
missing.
something. We have something only. So what is
Okay.
that missing? What is the thing that is not fitting into our equations? That is still a variable.
Right. Okay.
What is that which
Uh,
we want to fulfill? So that's something like dark matter
It's
That's what.
12:30.
or dark energy.
So, what do you guys think? We have been streaming for 3 hours.
Oh my God. Okay.
That's what happens. Even last time that had happened.
We did for 2.5 hours with my exam the next day. Same case.
Yeah.
Same.
So, chat, what do you think? So, okay, how long do you think we can cover the galaxy bit now, and then we'll stop at dark matter? We won't touch on dark matter.
No, the galaxy will take
Galaxy was
another an
the
hour,
next. Yeah.
another hour.
Okay.
Yeah.
And basically, to touch on the dark matter, we need a base of galaxies.
Yeah.
Okay.
So, like, it's like understanding galaxies is not something like you need something that we talked till now. Obviously, you need precursor hai,
Right.
but
But yeah, you can't understand dark matter without understanding galaxies.
yes.
Yeah.
All right.
That's why if it's in a continuation, then it's best.
So today we talked about how stars are formed.
Hmm.
We talked about nebulae.
Ellen.
We talked about red dwarfs, white dwarfs. We talked about what happens when a star dies, and then we talked about black holes.
Yeah. And black holes, so we haven't even like touched
Yeah, we
everything.
haven't really touched because
Yeah.
we shouldn't. Guys, avoid black holes.
Yeah.
And
Once you go black, you'd never come back.
good God, Atharva. This is a family stream. No, it's
Yeah.
not. I'm kidding. It's not. It's really not.
You could have just said social distancing, but you had to say that. Okay.
All right.
But
Yeah.
okay.
I think that, yeah, I think we covered a lot.
Yeah. It
And
was,
if you're going to talk about galaxies, what do you think? We'll do it justice next time?
yeah, we will. So,
Can we? Okay, promise me you'll talk about dark matter next time.
oh yeah.
Yes.
Yeah.
Yeah?
Yes, we have to.
Galaxy के साथ वो आता ही है.
आता
आता ही है.
और
It is there. And that's my field. That's my field.
oh,
The
that's
third
your
talk
field.
is my
अभी तक
field.
ऐसे ही फेंक रहा था. क्या? What is this?
This is the precursor you need to get to that field, right? So that's my field.
Oh my God! All right.
Okay. Before like we go,
Yeah.
I want to show something.
Sure.
Please ignore. Please don't see the spoilers for the
Okay.
next.
Okay.
Yeah.
Everybody close their eyes. Everybody
Yeah.
close their eyes.
Open your eyes now.
All right. What are we
So-
looking at? What are we looking at?
We say that there is a black hole at the center of a galaxy.
Yes.
We actually managed to capture the data and observe the movement of the stars
Mm-hmm.
at the center of the galaxy. And this is what got Nobel Prize. So you can see that the star, it just moves and suddenly उसका पूरा path ऐसा ये होता है.
Oh.
Just goes-
Because it's like sling.
Yeah, it's a
Ellipse है.
sling.
At one focus there is one the black hole, and then it's rotating and like sling. It goes up.
Damn, that was so cool.
I know, right? I just wanted to show that we have managed to see that.
Okay, and hang on. On the top right, you can see the time.
Yeah.
Yes.
Is that the year?
Yeah.
Yes.
yeah.
Yes.
It took 10 years to just get that sling.
Sling.
Oh wow, this is so unbelievable.
And this guy is an epic. He's an epic guy, Reinhard Genzel. So he's in the Max Planck Institute of Extraterrestrial Physics.
Huh.
Yeah, we have to do this
Wait,
thing also,
what?
like
Aliens and
further
There's an
career
extraterrestrial physics
options.
करके there's a department.
Max Planck Institute for Extraterrestrial Physics.
Oh
So
my
this
God.
guy is a very great. I read his research work. I was going to drop in him an email of like discussion on what project opportunities could be there, and I was going to schedule the email for 2 days, in advance.
Huh.
And the next day I saw the black hole news.
Shit, dude.
I saw the Nobel Prize news. I was triggered. I didn't even send that email. I was so triggered.
Oh, you should have. You still can.
yeah.
You should just
Yeah,
do
but-
these things.
just randomly.
Because
And
these people are
honestly,
open for discussions. These people
yeah,
are very good researchers.
Exactly. So you should. Okay, I'll give you a small, like a piece of personal lesson that I've learned. Like, try to voluntarily increase the level of chaos in your life, just the right amount, for very interesting new things to happen.
yeah,
Right? So we think that being very much in control is what will get you everything, but you need a certain amount of chaos for really awesome things to happen. So yeah, just send the mail. Send it.
I mean, I
Yes.
am here. Like, we are here because I sent you a text SE
Yeah.
randomly. So,
Yeah,
just
increase the. I mean, yeah, I think even Meenal reached out
No,
just.
yeah,
his
yeah, yeah.
collaborator actually replied to my mail,
Okay,
Professor Kirpal Nandra. So like
amazing. Chaos is a
his
ladder.
collaborator very close.
What's his name spelled? Uh,
Who's?
You can put
can
it
you
on the
type it in the
Discord.
chat? Can you type
Yes,
it
yes,
on?
yes.
And of course, like
Reinhard
after this, I think Discord
Jansen.
will have a lot of
Oh,
discussions.
I'll put the PPT on Discord as
Yes,
well.
please.
Yeah,
But then remove the next slides.
yeah, I will.
Yeah, amazing, amazing. Sid is on Event Horizon of OBS right now. Yeah, that's true. Wait. Oh, wait. Okay, that's why my face is all messed up over here. Hold on.
Oh, I stopped sharing the screen. That's
Yeah,
why.
exactly. You should warn me.
he's on event horizon.
I am so sorry.
No, that's okay. But guys, so I actually put. I mean, I know that's not Event Horizon, but that's just some horizon. Like that is the OBS setting. All right.
It was.
Meenal, Atharva, as always, you guys have blown my mind. This was pretty amazing. I don't think YouTube live streams happen on these topics. I don't think conversations like this happen on YouTube. And
I know only one person who does those
Neil
conversations.
deGrasse
Neil
Tyson.
deGrasse
Neil
Tyson.
deGrasse Tyson. So if we are in a conversation where we say the only other person who does this is Neil deGrasse Tyson, we are in very, very good company.
Exactly.
Absolutely.
So
Oh,
yeah,
okay.
I think we are good. I think that this was superb. I can't wait for the next one. Hopefully we'll do it. We won't have a gap of 2 months. Let's
Oh,
try to not.
Yeah.
I think so. I think it's been 2 months. I'm not sure, but
It was some October.
Yeah.
My quiz was on, so
maybe I
like
don't know. Anyway, it was too long, basically.
Yeah.
Right? So
Yeah.
let's try and do it in December itself.
Okay.
Maybe the last week of December.
Chalega.
Yeah.
We'll end it
New Year
with
Eve,
dark matter.
Christmas Eve.
Yeah. Just remind people one more time that it's all meaningless.
Discord
guys.
link.
It's all
Yeah.
meaningless. It's fine.
ये न्यू
Yes.
ईयर सेलिब्रेट करने की भी जरूरत नहीं है.
Yeah, I know.
You will just be like, अब मोह है, why celebrate New Year's?
Yeah, I mean the sun is becoming a red giant. Beetlejuice is going to explode. What's the point? Just घर बैठो.
चुपचाप जो है खाना खाओ मजे मारो.
Animesh, I've missed the bulk of it. This stream is going to remain public.
Meanwhile,
Don't
people are
worry.
asking keyboard.
What? Piano?
Oh,
Yes.
oh
Oh,
yes.
Do we have time for that?
Yeah. Play something.
अरे
Okay.
5 minutes.
Now we're just chilling.
Time.
Now we're just chilling. Time
One
is not real
interstellar.
anyway.
Only one interstellar. Cornfield chase.
Interesting.
Oh, do you know
Good,
Interstellar?
okay.
Obviously, that's the best thing.
No, but do you know Interstellar music?
Saurabh
Wow.
Saurabh Tambe is asking for shout. Bro, shout out, bro.
Alright, I think you did that. Thanks.
Okay, it's on.
Okay.
Please just forgive my mistakes if I make
No,
any.
we won't know if it's a mistake. But yeah, we will. I hope that it'll be audible. Just play it out. Play something. And
You
let's
know
see.
who just became max emotional. Let's hope the next astrophysics stream isn't when the sun is red giant.
Okay, Meenal, can you play something? I can't hear you.
She hasn't yet
Very
started.
low, very low. What system are you on? Do you have a mic?
Yes, she is on the Mac.
No.
I can put. laptop closer to the piano.
Yes, that would help.
Just a minute.
Yeah. You can switch off the video for a second if you want to. Otherwise, it's fine. All right.
Oh, no, that's fine.
Meenal is going to give us, after that amazing PPT, she's going to give us... Oh,
Can you hear?
copyright incoming. Damn, okay, I didn't even think about that. But yeah, that's okay. Just play something you like.
Can you hear?
Yeah.
Bubble mute पे जा.
Yes.
So, okay, we'll both go on mute so that, yeah.
Okay. Let me know when it's not audible. Yeah.
Oh wow.
Let's just take few seconds to absorb. Why did you end it?
That was so good.
Thank you.
All right. Just look at the chat. Just look at the chat, man. Unbelievable. Very nicely played, Meenal. That was beautiful.
Thank you. Thank you, Mansima.
Yeah. So I remember that you had done you had read Carl Sagan's speech the last time, and that was pretty hard to beat. But this one was.
Next time something much harder to beat.
Oh my god.
No.
The bar has been escalating since
I
last
think
time.
now that I know that you can do this.
Why didn't you take the guitar?
After this, no. There is no better way to end the stream. We can have a guitar session completely. We can have a full guitar session. I don't mind. But this was just perfect.
Yes.
Yeah, I don't want to do anything else. Thank you, both of you. This was amazing. I learned a lot. I felt a lot. And I think chat is with me. Chat is just going all out, all hard. Next time Atharva will sing.
Oh no, what? Why?
Yeah.
Do you want to ruin all the entire series?
This was amazing. Alright, chat, thank you so much. You guys are wonderful. You were really with us throughout the stream, and that was amazing. Yeah, I don't have anything more to say. Thank you so much, both of you. Yeah. Meena.
Just if we made any mistakes in the video, just comment it so that other people know that we develop time. Like, they don't get.
Are you not audible neatly?
तेरा volume बढ़ा देना.
Oh, hello.
Yeah. Just say it again.
I was saying that if like we made any mistake during the video, just comment it so that it's other people also get to know that.
Yeah.
हाँ मतलब technical theoretical कुछ mistake हुई होगी.
Yeah, of course, guys.
It just gets some time in the flow and just like few things can go off the chart.
Absolutely. I mean, that happens, and I feel like if you're trying to teach something, if you're afraid of that one mistake that you make and you use that, because of that you don't teach the 99% that you know, I think it's a tragedy. I think you should teach, make mistakes, let people correct you, learn from it. It's fine. Yeah. And we'll continue this discussion on Discord. There is a whole channel just for astrophysics. So I'll see you all there, chat. Thank you again for being such a lovely audience. And I'll see you soon.
Yeah, thank
Bye,
you.
guys.
I
Good
guess
night.
I guess next time we should end it with some career oriented things, maybe.
Yeah. Career opportunities.
We can
Those
feel
are
like,
important.
I feel like these streams we can't plan much, but I think anything is possible. We can end it with anything.
Yes.
Absolutely. All right.
Okay.
Good night.
Okay,
Good
fine.
night, everyone.
Good
Good
night.
night, chat.
Good night.
I'll see you soon.
Good night.
Bye.